Hello, 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 folks. How we doing? I hope y'all are having a great day today and a great weekend so far. How's everybody doing out there? We're gonna get started here in about 1 minute. I'm really excited about today's topic. I hope you are as well. I'm always excited about our topics. I mean, I pick them, but today we're gonna be doing something pretty near and dear to my heart. So I am pumped to show it to you guys. Hey, Pod. I'm actually catching a live stream. Hey, I'm happy to have you here too, Apod. Good to see you. Welcome to the stream. And welcome into everybody else as well. Also, too, I wanted to say thank you to Romandalorian for being my 6,400th follower. Right before the stream started, they followed me, and they are now my 6,400th follower. So thank you all so much. I really appreciate all your support, and so happy to have you all here. Okay. Hey, Mattel. Yeah, my goodness. Good to have you here right at the start. All righty. Hi, hello, hello. Welcome in, everybody. Today is going to be a great stream because normally we like to do projects from start to finish here on stream, but today we're going to be doing the type of stream where you can pop in and out whenever you want. There's no such thing as arriving late today because we're just going to be doing a bunch of code wars. But the difference is we are actually going to be doing them against a real database, a database that I built that is hopefully going to help illustrate how queries work, what they do, and what the different parts of queries do, and particularly SQL queries. So if you've never used SQL before, maybe it's a little scary, maybe you're not sure how to do it. Hopefully this stream will be helpful to you, showing you how easy it is to translate real world requests into SQL code. Hey, Copper Lily. Hey, Genpo. Good to see you. Hey, Ian. Nice to see you. Thanks again for the raid last time, by the way. Wizard is never late. They arrive precisely when they need to. Of course they do. Yes. All right. So, what are we doing today? We are doing SQL Code Wars, and I'm assuming most folks here know what Code Wars are. But if you don't, they are essentially little mini code practice problems. So there's a whole website for this. It kind of makes it into a little bit of a game. There's a bunch of questions, usually very small, self-contained type questions in a variety of languages, and you could basically do it to help quiz yourself and level up on the basics, get that memorization in your brain, and okay, KT, good to see you. Welcome. Hey, Papa Alpha. Welcome, welcome. Good to have you both here. And so, yeah, Code Wars is great for practicing. And so, what are we going to do today? We're going to practice some fundamentals. And so, what better way to do that than by answering some Code Wars questions together? How many of you have used Code Wars before? I mean, I'm assuming most of you have. And I'm not saying use Code Wars for SQL, but just use Code Wars in general. Simo says I need to get back on my Code Wars routine. Well, we're going to give you some easy points today. Papal said, nope. Yep, every day. Yep. Okay. All right. Well, yeah, again, Code Wars is a great fun way to practice. I'm sure that most folks out there who are watching me now have used Code Wars for JavaScript, probably. But you can use Code Wars for other languages as well, including SQL. And so if you are in Code Wars and you go to the practice section, you can actually choose whatever language you want to practice in. And so today we've chosen SQL. But what you might notice is that over here on the right side, let's see, I got Reddit open in the background. Over here on the right side, it shows you all the languages that a question is available in. So for example, this question here, quarter of the year, it's available in tons of languages. I've already completed it in JavaScript, but it's also available in SQL. And so for some questions are only available in SQL, they're very specific. Other questions are available in a bunch of languages. So if you've completed a question in JavaScript and you want to test it out in SQL, you can do that as well. And so we're going to be doing that with, for example, this question and several others. Hey, EVCAD, welcome. All right. Now, The slightly less cool thing about practicing Code Wars in using SQL is that Code Wars doesn't really show you tables. And so let me give you an example. The first question we're going to do is search for it here. This one right here, SQL for Beginners number 1. And if I click on train, it tells you for example, what the question is and what the table schema is. User's table schema has name and age, but it doesn't actually show you the table. And so if you want to build a query and test it, it makes it a little bit harder because you don't know what the table looks like. You can't do sort of incremental tests against the table to see if you're getting the results that you want. It's kind of difficult to do just in Code Wars itself. So what I've done for y'all is I've made a whole friggin' database where the tables are in there already for each of the questions that we're going to do today. I've built the tables. They're in there already. We can build our queries. We can run them over and over again. We can test them. And we can see exactly what each part of the queries that we're writing actually does. Okay? So hopefully this makes it easier to understand when we write a query what each part of it is doing. Hey, Dylan. Hey, Kiro. Good to see you. Hey, Evie. Welcome to the stream. All right. So, does anybody know what do we mean when I say SQL? What does that stand for? Does anybody know? Hey, Mo too. I'm glad you're excited. I'm excited too. Squeal. Good guess. What is SQL? Dylan, yes, structured query language. Exactly, structured query language. Um, Structured query language, abbreviated SQL, and often pronounced SQL. Um, Something query language. Yes, it is a query language. It's used for talking to databases. Now, there's lots of reasons why you might want to talk to a database, right? You might want to do some data analysis. So, a lot of companies have large databases and they have analysts who do analytics against those databases. You might be building an app that has a relational database as a backend, and you use SQL to pull data out of that database, to write queries against the database to pull data out of it. And so SQL is built to work with what we call relational databases. Now, I'm sure that many folks on here are familiar with MongoDB, which is what Leon uses in 100 Devs, and what uh, it's a something that I'm sure a lot of folks are familiar with who are in 100 Devs. And so MongoDB is a database, but it's a different type of database. It's literally what's called a NoSQL database, where all of the elements in it are individual objects. They're documents, right? You know what those are. However, relational databases are SQL databases. They are a different type of database where data is stored in what we call tables. And you can think of tables as basically like giant Excel spreadsheets. And it's literally what you see here. It's a table is a sequence of columns and then rows which contain data for those columns. So this is an example of a database table. It's a very flat, simple way of storing data. And by far, relational databases, SQL databases, are the most common type of database storage on the planet. They've been around since the 1970s. SQL has been around since 1977, and it's still in wide use today. I am a senior SQL developer at my day job, and SQL is everywhere. So if you can learn a little bit of SQL, Blue Arts
Fluid_ just followed.
Thank you for the follow. If you can learn a little bit of SQL, no matter what your role is, whether you're a data analyst, whether you're a JavaScript dev, whether you're a front end dev, doesn't matter what your role is. If you can learn some SQL, you will be valued, and you're going to get some extra kudos at your job if you know SQL and you know how to talk to a relational database. Dan Can Code, thank you so much for the sub. Good to see you here. Thank you, thank you. Evie says, I use Postgres at work, but the class I'm taking right now is using MongoDB. It's odd. Thank you, Dan.
Dan can code just subscribed with Prime.
SQL
SQL Secrets Plaza.
Plaza. Ah, hey, Axel. Welcome to the stream. I'm from the United States. Yes. Thank you so much, Dan. I really appreciate it. Dev Puddle says simpler than Mongo. Yeah, it depends on how your mind works, right? If you started with Mongo, SQL might seem a little weird, but I think it's good to have a grasp of both sides of it. So no matter what type of database you encounter, you know how to interact with that database. Um, RDT, thank you so much for the sub. My goodness, I'm feeling some love right now. Wow. Oh, Axel, you're from Mexico. That's awesome. Good to have you here. Um, Okay, so today we're going to practice some basics with SQL so you can impress your employer, so you can impress the recruiter, so you can put SQL on your resume. Now, SQL is an interesting language because it, like I said, it was created in 1977. And that was before most people had ever even seen a computer, much less used one, right? So SQL was written to be the type of language that is written and sounds very similar to English. And I'm going to show you what that means by doing a demonstration on our very first question here. So we're going to do a code wars called adults only, which it's a little weird, like the question itself is a little weird, but I think it's a good simple one to start with. So let's read it. And we're going to say, all right, in your application, there is a section. Oh, Nico, thank you.
Ilko the Tiger just followed.
Thank you for the follow, Tiger. Spicy stream. Not really. Not ain't that kind of stream. All right. In your application, there is a section for adults only. I don't know. We're just gonna say it has something to do with like liquor licenses or something. We're not gonna get too weird here. You only need to get a list of names and ages of users from the users table who are 18 years old or older. And they give us a schema. So we know what a schema is, right? You've used a schema before when you build a MongoDB database. You would use a schema to set up what values are going to be in your documents, right? And SQL does the same thing. It uses a schema or a blueprint to describe what values are, what columns are in the table and how they're constructed. So in this case, our users table has two columns, one for name and one for age. So let's pop on over to Supabase. And I've already built the table so we can clearly see what it looks like and what kind of values are in it. And we're going to build this query against this table to return a list of names and ages of users from the users table who are 18 years old or older. Okay, now how do we do this? Well, let's think about the request as if we were to spell it out in plain English. All right, so I like to pretend that maybe I'm talking to the computer from Star Trek. In Star Trek, they just say, like, computer, dictate a log entry, or computer, I don't know, make me a plate of spaghetti, something like that. It's very declarative. It's very, you request something and that's what you get. So let's think about this request in plain English. I'm going to say, give me a list of names and a list of ages from the table users. Oh, thank you, Dav.
Zuniga just subscribed with Prime.
Thank you so much, Dav.
Streams.
I appreciate it. 6 months. Wow. Thank you so much. All right. So give me a list of names and a list of ages from the table users where the users are 18 years old or older. So that's as if I was asking somebody to go and get that list for me, right? Now we're going to learn how to translate that request into SQL. Oh, don't write it yet, Axel. We're gonna write it together, okay? We're gonna take things pretty slow. I'm sure you know the answer though. All right. So first off, we can see that I've written a very simple statement here to show all of the values in the table. This is probably the most simple type of SQL statement you could write. Select star from users. Whoa, hype train. Oh my goodness.
An anonymous user gifted 20 subscriptions to the community.
What? Thank you, Anonymous. I wish I knew who you were. Thank you. going to turn down the volume here a little bit, but not because I don't want to hear it, just because wow, like it's my alerts are going off like crazy. Thank you so much. If you just got a
Axel Jabo just followed.
if you just got a sub from whoever that was, please thank them. I guess we don't know who they were, but thank you, anonymous person. Nano Pony, thank you so much. Wow, indeed. Yeah, say thanks to Anon. And also, if you just got a gifted sub, you now have access to a bunch of really cool emojis. So check those out. Subscribers get super fun emotes on my channel.
Praisefulest just followed.
Hey, thank you for the follow, Kip. Take all the cowboy hats. That's right. Thank you. All right. So this is the most basic type of SQL query that you could possibly write. And what this essentially means is select or give me. So give me equates to select in SQL. Star means just get everything. And you may have seen the star on, the star used before. And technically it's called a wildcard. It just means, hey, give me everything. So select everything, all the rows, all the columns from, pretty self explanatory, and then whatever table you want to access. So in this case, we're accessing the users table. So give me everything from the table users. All right. Yes, exactly. That's a great point, Kiro. In CSS, you use the wildcard or the star to basically say, hey, apply this style to everything, right? So wildcard works the same way here as it does in CSS, if that helps you. Absolutely. All right, now let's modify this query to start kind of narrowing things down here a little bit. So what they want is a list of names and a list of ages. And because this table only contains names and ages, we don't have to get rid of the star. We can leave the star there. But in a minute, I'm going to show you another way that you can also access this data. All right, so select star from users. Now we need to add a filter to say where the users are 18 years old or older, right? So SQL has something called a where clause. So literally, just like we would say in English, we use the word where to add a filter to our query. So if I want to only get people who are 18 or older, what might I say after the word where? Think about how you would do it in JavaScript. Let's say I had a variable called age. If I wanted to get ages that were 18 or older, what would I say? Oh, thank you, Ryan. Yeah, Tame Mister. Exactly. Yes. So where age, right? My column is called age, where age is greater than or equal to 18. So these types of expressions, these types of basic conditionals, they work exactly the same as they do in JavaScript. So select star from users, select everything from users where age greater than or equal to 18. Let's run it. Hey, look at that. It gave us exactly what we wanted, right? Just age. Yes, exactly. Yep. So you can see there's some similarities to how JavaScript does things, right? This would look the same way as if you had a variable called age in a JavaScript function and you wanted to, filter on that on something like that, right? It's exactly the same. Yes, and you could also do age greater than 17, exactly, just like you would in JavaScript, right? So I like greater than or equal because it matches what the wording of the question. But you could do either one. Now, this is the answer, so we can go ahead and submit the answer. Kiro says, could we do select name from users where age greater than or equal to 18? Well, let's see what the question is asking. Okay. Oh, thank you, Dav. I'm glad you're using SQL today. Yeah. Wow, and thank you all for the hype train as well. That's incredible. Thank you again to the anonymous gifter who just gifted 20 subs. Y'all are nuts. So let's look at what the question is asking. You need to get a list of names and ages, right? That's what the question wants. Yeah. But let's let's experiment a little bit. Let's say that I do just want the names back. I still care that I want to, people to be 18 or older, right? But I don't need to see the actual ages. I just want to see their names. So I could do that. I could just say select name from users where age greater than or equal to 18. So even though I don't return the ages, I can still filter on them. So let's run that. There we go. And I get back a list of names. Okay. Interesting, right? Yeah. So you can filter on things even if you don't return them in the result. And also, too, just as an FYI, SQL doesn't care about white space or like indentation or anything. So I could put this on one line if I wanted to. If that makes it easier to read, we can. Normally, you don't write it that way, but if I put it like this, you can really see how much it matches that sentence that we wrote, right? You can read it almost like a sentence. So I'm going to put this back to the star. So select everything from users where age greater than or equal to 18. All right. Papa, we're not actually in Code Wars right now. We're in Supabase, and I just pasted the question into Supabase. So we're going to go back to Code Wars, and we're going to submit it, and we're going to make sure that we're right. Okay. All right. Let's take this, and we'll see if we got it right. Yeah. Because in Code Wars, you don't actually have real tables to test against. And so it's a lot easier if I just demonstrate to you in a real database. And then we just put the questions into Code Wars. All right, let's make sure to get the list of names and ages somewhere. Okay, yep. Let's test it first. Hooray, we passed the test. Yay, now let's submit. I'm clicking the submit button. You can't see it, it's behind my head. Hooray, we got it. Go us. All right, let's see if anybody did anything different. Yay, indeed. Yeah, so if you look, the top answer is very similar, but it is slightly different. So what they've done is they've said select name, comma, age from users where age greater than or equal to 18. And that's a perfectly acceptable answer. You can also specifically specify what columns you want. So we could have said select name, comma, age from users where name greater than or equal to 18. That returns whatever specific columns you request. So in our case, either one works just fine. All right. Axel says, "Are you front end or back end?" I am a back end dev, although I do full stack for fun. Mostly on this stream, I do full stack web apps, but my day job, the thing I actually get paid for, is is back end only. So, all right. Any questions on this before we go? We're gonna do a bunch of questions today. We're just gonna keep hitting the same concepts over and over and over again, and by the end, you all are gonna be absolute professionals at writing your own queries. All right. Hey, Honda Civic, haven't seen you in a while. Hope you're doing well. So, any questions on this? First try. Yeah. Third Decade says, is Supabase another code editor? Supabase is kind of like MongoDB. It's where you can set up your own SQL database and store data in it and use it as a backend for your apps. So I'm using Supabase today to literally just generate a bunch of tables for all these Code Wars questions. You can see I've got my generate statements here. And then we are literally querying the tables that I have made um, in these in these queries right here. We're querying tables that I built yesterday. So Supabase is sort of like MongoDB except for SQL databases, for relational databases. Yeah. Papa says, should we be in Supabase too? If you want to. However, it's going to take a while. You'd have to build the whole database yourself, so that takes a while. So it's probably not worth your time. It's probably just best to watch along and build the queries along with me, and then you can put them in Code Wars yourself and get some points in Code Wars if you want, because we're all working together on this, right? Renit says uppercase versus lowercase. Yeah, that's a great question. So traditionally, Because it's from 1977, SQL literally existed before computers could write things in lowercase. It was everything was uppercase all the time. So traditionally, SQL is written mostly uppercase. Um, however, it's easier to type in lowercase rather than just having my caps lock on all the time. So it doesn't it SQL doesn't care about case, but traditionally the convention is uppercase for keywords like select and from and where. And at work, I actually the SQL editor that I use at work actually automatically, like I've set it up so it automatically puts things in uppercase for me, so I don't have to do it. It just automatically capitalizes all my keywords because I'm lazy. Yeah, the convention Copper Lily is that keywords are mostly uppercase, but it doesn't really. RDT says is selecting specific rows from the second way faster than selecting all rows with star. I assume are you talking about this, like this part? This is where we're selecting columns. So we'll see more examples of this later on. Don't worry. In this case, it's 6 of one, half a dozen of the other. But let's think about what would happen if your table had 100 columns. If your table had 100 columns and you did a select star, and I'm not talking about rows here. Remember, rows are vertical. Rows are these things right here. Columns are horizontal, the headers across the top, right? So if my table had 100 columns, which is not uncommon like at a company, um, I would probably want to be very careful about which columns I actually need. I would not want to select all the columns because that's going to take a long time and a lot of resources. So there you would specify exactly which columns you want, like so. Now in this case, it literally doesn't matter because we only have two columns, but that's something where if you had a lot of columns, you would want to be very explicit about which ones you needed. Okay, great questions. So, automatical capitalization, yeah. Renit says, are column names case sensitive? So generally what you'll find is that in SQL databases, columns are either going to be entirely lowercase or entirely uppercase. So in this case, name like these values here are coming out of Supabase as lowercase. I'm trying to remember what did I do for. Let me see for table users. Yeah, so when I created this table, I created them as lowercase, and so that's how they come out. But like at work, the convention for all the tables I create for my job at work, everything is uppercase. Okay, where were we at? Sorry, find it again. Oh, here we go. Okay. Dan says, okay, question. On a table with many columns, it's faster to select fewer, or just a concern about the amount of data? A lot of times it's faster to select fewer. You will get a faster result from the database if it has to scan through fewer columns. The more you can narrow down your query, the faster you get data back. So it is a concern, yes. Nano says 100 columns equals bad table. Yeah, but it happens. It absolutely does. Okay. Nerd Girl says, I know this is a bit off top, but what would documentation for SQL look like? Well, I mean, every table has a schema, so you would describe what the columns in the table are, what their type is, because SQL is a typed language. So if you when you build a MongoDB or a Mongoose model for your MongoDB database, right? You have to specify like the name of the key in your document and the type, right? String, integer, whatever. It's the same way with SQL table schemas, except in SQL it's required. SQL is a typed language. It cares about what type of values you put in this column. So when I built this users table, I had to specify that the name column is a varchar, so string, and age is an integer, so a number, right? That's required. You have to do that. And so that's kind of how documentation looks for these types of tables. All right. Um, let's do another one. The more we do, if you're still kind of stumped on what's going on, Not quite understanding it yet? That's perfectly fine. We're going to do a bunch of these. Like I said, we're going to keep hitting it, and you'll see that the repeated concepts and how they work as we go. Rex says, sorry for the tangential question. Do you ever do streams on how to build a portfolio? We do lots of streams on how to build all kinds of projects. I have a YouTube archive if you want to look through it. Do !YouTube in chat to get a link to my YouTube channel. That's where I have my entire archive of all my past videos, tons of cool stuff on there. And you can learn to build pretty much whatever you want. I don't have a raffle, Dan. I'm sorry. Okay, let's do another one. How about, let's see, let's look at this one. Okay, here's a good one. You are working, let's see, and actually let's pull it up in Code Wars as well. Collect tuition is the one. So this is the Code Wars we're doing now. If you wanted to, put in the code when we're done and get some points, this is called Collect Tuition. And this one is, you are working for a local school. Sounds familiar to me. And you are responsible for collecting tuition from students. You have a list of students, and some of them have already paid tuition and some haven't. Write a select statement to get a list of all students who haven't paid their tuition yet. The list should include all the data available about these students. All right, so here's our schema. Here's our blueprint of what the table looks like. And I'm going to show you the table in just a second. It has name, which is a string, age, which is an integer, semester, which is an integer, mentor, which is a string, and tuition received, which is a Boolean. What is a Boolean? When we say Boolean, what does that mean? Yeah, it's true, false. And yeah, I'll put the link for the Code Wars in chat here. Exactly, guys. Yep. So tuition received is going to be a true or false value. So based on what this question is asking, it says we want all students who haven't paid for their tuition yet. So if I'm looking at the tuition received column and those values are true or false, which value am I going to be looking for? For all students who haven't paid their tuition yet, what value am I going to need? Chicken Boolean. Ah. False, exactly. We're going to be looking for something about all this student data, and then any student where tuition received is false. Exactly. So let's build our query. So we can see here that I've done a select star to see what type of data is in our table. And in this case, we've got our names, which is a string. We've got age, which is a number, semester, mentor, and tuition received. Now, we've already said we want to filter this column down to only false values. So let's write out our question. Give me a list of all student information. Oops. Where the tuition received value is false. Okay, so let's do it. Give me, which is equivalent to select, so we have that already. Give me a list of all student information. I'm going to say from the table students. All right. All student information is equivalent to the star, right? Select everything. Give me everything from table students. So we're saying, all right, give me everything from table students. So we're already halfway done with the query. Now we want to put a filter on the tuition received column. So once again, I can use the where keyword to add a filter, where, and then I specify which column I'm filtering on. It's going to be tuition received equals false. Okay, let's try it. Exactly, as Kiro said, yep, select star from students where tuition received equals false. Let's run it and see what we get. No, it's okay, Kiro. Hey, there we go. So Bob, David, Grace, and James have got some splaining to do to the university bursar. They're going to be coming after him for that missing tuition. Kira says, this is way more intuitive than I thought, right? It was literally written that way. It was written so that people who had never even touched a computer before could sit down and start talking to a database. Because in 1977, nobody had seen a computer before, right? They were as big as, I don't know, my house. And so that's why the language is written the way it is, because it's meant to be intuitive. It's meant to sound like you are writing an English sentence or telling somebody to go get you something. Parasocial. Thank you for the raid.
Parasocial Fix just rated with 3 viewers.
Right, Sue says, wow, you have a big house. I really don't, but I get what you're saying. Yeah. Yep. So it's really not that hard, right? The basics of it are really not that hard. Um, hey, Parasocial, your first raid. Well, thank you so much. I feel honored. Good to see you. I hope you're doing well. Were you doing something fun today? Now, let's just for funsies, and this is the right answer. This is going to work to answer this question, but just for funsies, what if I wanted to not only see the students where tuition received equals false, but also I wanted to sort them by, let's say, their semester. Maybe I want to go after the person that um, has been in school the longest, maybe person who's on semester 4, maybe I want to go after them first and get their tuition first because they owe the most, right? Maybe they haven't paid for all 4 semesters, and that's really important, and we got to go track them down, right? Oh, you're re-recording your talk. Oh, that's rad. Awesome. Yeah, I gave a talk a couple weeks ago. Maybe I should record that. Yeah. So what if I wanted this result set to be exactly the same but ordered in order 4, 3, and then 1? So how would I do that? Now, if we're thinking about writing in English here, I want to put these in a specific order. So what keyword do you think I might use? You don't have to think too hard about it. There absolutely is. Oh, yeah. Order, right? We're going to literally use the keyword order by. And what do I want to order by? I want to order by semester. I want to order by the values that are in the semester column. Exactly. So let's do this first and let's see what we get. Yeah, so I get 1, 1, 3, 4. It automatically puts them in ascending order. But that's not what I said I wanted, right? I said I wanted to put them in reverse order. Exactly, Ryan. How would we do reverse order? So these values are in ascending order, right? So what would I do for reverse order? Once again, don't have to think too hard. It's all very, intuitive. Yes, exactly. As Yarmo and Infidel said, descending, right? If it sorts by ascending by default, we can just say descending. Now, I'm not sure. I always use the abbreviation DESC for descending, but I don't even know if you can we do that? No, it's got to be DESC, I think. Yeah. So ascending by default, descending if you want it in reverse order. Nope. Is it not going to let me do that? Order by semester. Let's try that. No? So this is how I would do it in Oracle. Maybe there's a different keyword for Postgres. Because this, by the way, Supabase works in Postgres, which is not what I normally use. But how do we do? Somebody Google descending sort in or descending order in Postgres real quick. Because yes, as Yarmo said, I would normally do. Yeah, maybe it's a semicolon. Oh, there we go. Yeah, it's descending. Okay, I was missing the semicolon at the end. I'm a dingus. I was like, it shouldn't be any different. It's always the same. Yeah. So when you complete a statement like this, technically SQL does require the semicolon. A lot of times I don't do it, just like I don't do it in JavaScript, but it's going to make me do it there. So I'll try to be specific about it as we go. Thank you for that. Yes, good catch there, Rex. I know it didn't complain about the semicolon before. SQL is very weird and finicky about semicolons, so I don't even sweat it at this point. When in doubt, add a semicolon, it'll probably work. Yeah. So now we can see that it's sorted it in descending order: 4, 3, 1, 1. And if you wanted to be explicit about it and sort it the other direction, you could also say ascending. So ascending or descending. Both of them will work. 1, 1, 3, 4. We switch to descending. 4, 3, 1, 1. Thank you for the follow, Thomas.
Thomas Reggie just followed.
26, yes. I'm teaching a class. We're talking about the basics of SQL by doing some basic code wars. Yeah. So we're learning. If you're not familiar with SQL, feel free to join us. Now let's go ahead and pop this into this code wars right here and see if it works. Now in the code wars itself, they didn't ask us to sort it, so I've removed the order by statement, but I was just kind of showing that for funsies. All right, so select star from students where tuition received equals false. Definitely pass the test. Now let's attempt it. Absolutely, me too. So in 26, I am also a backend engineer, and I work with SQL every single day, and I have been for my entire career, and I love it so much, and I want other people to see the beauty of it too. So that's why we're doing it today. Absolutely, I completely agree with you. It is a vital language. I agree. It's literally everywhere, and if you know it and you put it on your resume and you can demonstrate that you know it, um, yeah, recruiters are going to love you. All right, let's attempt it. Yay, it worked. All right. So I'm going to submit this. And of course, because it's Code Wars, people have to be fancy. This is the version that we did. I think this is the second one here. This is the version that I think makes the most sense. But people got to be fancy because it's Code Wars, and so they did it a slightly different way. You could also say where not tuition received, and it would work the same. But this is far more easy to understand, in my opinion. Yeah. Yeah, so 26, we're actually going to do an example later on that does deal with subqueries. So, yep. If we have time, I hope we will, because yeah, subqueries are cool, and they're a good thing to know. But I definitely want to get the basics down first. I do have a subquery example for later on if we get to it. Yeah, E1. If you're a front end dev and you can learn some SQL, you're going to be like a unicorn. If you have good front end skills and SQL skills, yeah, you're going to be a unicorn. All right, so let's do another one. We've done this one and this one. Let's do this one next. Oh, and I didn't put the question in there. So this is going to kind of piggyback off of what we just did. So we're going to get some more practice here. I'm going to have you guys help me build this one. All right, easy SQL ordering. So we'll find the question. Here it is. So your task is to sort the information in the provided table companies by number of employees, high to low. Returned tables should be in the same format as provided. So our schema here, our blueprint, is ID, CEO, motto, employees. Okay? So we have our schema here, and I've already built the table for us. So this one is, and I'm also going to copy the question here. So we have it. I'm going to have you guys help me build this one. All right, and if you're familiar with SQL, please don't put the answer in chat. We're gonna, if you're already a SQL pro, let's let folks puzzle it out here a little bit. All right, let's write it out in plain English first. So give me all the information from table. What is this? Companies sorted by Number of employees. Now, when they say sorted from high to low, is that ascending or descending? Sorted from high to low, is that ascending or descending? Exactly, yes. Number of employees descending, right. It's easy to get those turned around if you're not thinking. All right, and we've already done a select star to see everything in the table here, and we want to sort by the number of employees, right? Number of employees descending. So how might I do that? So
just followed.
Memoris. Sorry, I can't say it. Thank you for the follow. Um, Select. So give me all the information star from table companies from companies. Now we want to sort it, or maybe we should say instead order by number of employees descending. So what should my second line be here? Yes, Kiro says so. Order by employees. Okay, that's a good start. Let's run that and let's see what we get. Now, you don't always need a where clause. I saw somebody suggested the where clause, but you don't need a where clause if you want all the data just arranged in a different way. Okay, so let's run this and let's see what we get. Put my semicolon here. Best practice. All right, so it's sorted. It's sorted, but it's not high to low. The question wanted high to low. So what do I need to add here in order to make it correct? Kira says, well, descending now is missing, right? Yeah, so we need order by employees descending. Exactly. Now let's run it again. There we go. Yeah, exactly. DESC descending right after employees. So now it's sorted in the correct order, and they wanted all the information from it. It's sorted by count of employees descending. Exactly. Oh, thank you for the follow, Mehmet.
Just followed.
All right, any questions on this? Now, feel free to ask at any point. I'm going to keep talking, but you're allowed to ask questions. Um, you don't need a where clause here because we wanted all the data back. If we wanted to filter this data in any way, you would need a where clause. But in this case, we're just ordering, we're just sorting it. So we can still say, give me everything, just arranged in a different order. Okay? And you may have also noticed something about this table, that there's an ID column. So in MongoDB, what do we use? So in MongoDB, when you put a document in a MongoDB database, it assigns it like an ID value, right? So what is that ID for in MongoDB? What do we use IDs for in MongoDB? Thank you for the follow, horrible.
Horrible fart just followed.
To make it unique. Exactly, chaotic. Right, 100%. IDs in MongoDB make sure that every document is unique. We use IDs exactly the same way in SQL databases to make sure that every row has a unique identifier. So you'll see that a lot in tables. There'll be some kind of an ID value, what we call the primary key, which ensures that every single row is unique and you can always target a specific row whenever you want to. So, for example, in this case, it's very possible that, for example, two different companies could have like the same CEO, the same motto, the same count of employees. It's not likely, but it's possible. And in that case, you would still want um, them to have unique IDs so that you could target a particular row. I'm thinking like Elon Musk, it's way too involved in way too many companies, right? So it's possible you could have duplicate rows.
Kirama just followed.
But you would still want them to have unique IDs so you could target them individually. Okay? And Iwan says, so where is something like filter in JS? Absolutely, it is. Yes. Yep. So a where clause is where you'll find filters that help you narrow down the amount of data you get back. So you're exactly right. Hey, Chris, good to see you. Okay, any questions on this one? And you're welcome to ask questions at any time. I will ask for questions, occasionally, but questions at any time are perfectly fine. You don't have to feel like you're going to interrupt me or anything.
Space Little just followed.
Thank you for the follow, Space Little. Kiro says, so we could say where employees are above or under a specific number. Got it. Yes, we absolutely could. So we could say something like where employees, I don't know, greater than 900. So we could say that. And it would still give us all the columns, right? We're still doing a select star. It's still going to give us all the columns, but now we've filtered the rows to show only where employees are greater than 900. And then we've ordered those rows in descending fashion. Now you'll notice that I put the where clause before the order clause. There's a certain order in which these clauses, these keywords have to go, and where clauses always come before order clauses. That's something that you will forget. You'll do it wrong, you'll get an error, and then you'll fix it, and you'll be fine. For example, let's watch what happens if I try to put this where clause below the order by. Want to see the error that I get? It's not going to like it. Yeah, it's going to say invalid SQL query. Sometimes there'll be a specific error, but in this case, it's just like, nope, you can't do that. Try again. So we'll put it back. And now it works. Oh, thank you, 26. Uh, Gamamoresk says, what's the DBs good for? Databases are good for a lot of things. I'm assuming you're just asking in general what databases are good for. They're used for data storage. There's a database behind pretty much every single company, every single website, every single app that you have ever used. There will be a database behind it. And most often, it's going to be a database like this, a relational database, where it's a bunch of tables, and those tables work together to give the data, to give the app or the company or the website the data that it needs. And I mean, sometimes it'll be a MongoDB database, but really they are data storage solutions, long-term data storage and access solutions. That's what databases are for. Engineer Moore says, if we want to practice SQL later on, are there open source databases we can use, or do we have to create our own? You don't have to create your own. There are open source databases out there. SQL Bolt or SQL Bolt is a great SQL tutorial course. Also, W3 Schools, the website where you can Google stuff about JavaScript or whatever. They also have a great SQL sandbox where they have a pre-built database and you can just run queries in a sandbox and test whether or not they work. So W3 Schools has a SQL sandbox. If you want like a tutorial, SQL Bolt has a step-by-step tutorial that takes you through the basics of SQL. So there's plenty of resources out there. You don't have to build your own database like I did today. I was extra today because I wanted to have tables that were specifically tailored to the Code Wars questions, but there's plenty of sandboxes out there. Nicholas says, what about something like employees between 700 and 900? How would that be in the query? Sure. So what we would say is, well, you want employees between 700 and 900. So we could say employees less than 900 and I've been using lowercase this whole time. I'll just stick with that. Employees greater than 700. Or you could reverse that and have, employees greater than 700, less than 900. So if we run that, we only get one result. So if you want more than one filter in your where clause, all you need is the and keyword, just like as if you were writing it in a real English sentence. It's super simple. All you need is the word and. So if you think about it in terms of an English sentence, if you have if you're trying to list off a bunch of conditions in a sentence, you would say something like, give me all the information from table companies ordered by the number of employees descending, where the number of employees is greater than 700 and less than 900. And then you go ahead and you just use that same and keyword in your query.
Junkie underscores ice just followed.
Oh, thank you, Junkie. Yeah, and as 26 said, you can also create your own SQL database locally. If you're just learning the very basics and you don't know how to do that yet, I would use just one of the basic sandboxes that I mentioned. The W3 Schools sandbox is really good for just practicing stuff like basic select statements, because you can just dive right in there and immediately start querying stuff. Yes, and as Dan said, Postgres, what we're using now, to work inside of Supabase here, Postgres is also free. Yep. Um, and real quick sidebar. So when I say something like Postgres and Supabase, it might be kind of confusing as to what exactly I'm referring to when I say those things. So real quick, Supabase is the whole website that we're in right now. Supabase is kind of like MongoDB. It's the actual place where your data lives. It's the place where the data goes. Okay, it's where the data sits. It's the warehouse where the data is being stored. That's Supabase. That's MongoDB. Now, the language that you use to talk to that data and access that data is SQL. There are several different flavors of SQL. Postgres or PostgreSQL is a flavor of SQL. It's just a way that you write SQL code. And that's what we're using today. We're using Postgres as our way that we write our code. It's kind of like, you know, how there's one language of English, but there's different types of English. So American English, British English, Australian English. I don't know, other types. They all have different accents and they all have slightly different vocabularies, right? If an English person says crisps, I would say chips as an American person. But we mean the same thing, but it's different words for the same thing. But we're both speaking English, right? It's all under the umbrella of English. So there's different dialects or flavors of SQL that you can use to talk to the data in your database. Today we are using Postgres. But there's a bunch of different flavors. Postgres is not the flavor that I use at work. But the cool thing is, no matter what flavor or dialect of SQL that you're using, if you learn one, you can learn all the others. You can use all the others just fine. So all you need to do is learn one. Postgres is great because it's open source, and it's, you know, you can access it from anywhere pretty much. So Postgres is a great one to start with, and then once you have that, you can use whatever other flavor you want or whatever other flavor your employer uses. Okay. Yeah, and Nano, you know, you can get specific with like T-SQL versus PL-SQL, but I'm trying to be kind of broad here, and yeah, there's always semantics, right? We can get into that all day, but in general, for example, I started out in my career using T-SQL, and then my very next job, I started using PL-SQL, but I was still able to completely switch from one to the other with no problem at all, even though they are technically different. French fries, chips, yeah. Yes, exactly. There's differences, but we can all mutually understand each other at least to some degree. Rex Record said, "Would you recommend Supabase to build a portfolio?" Sure. If you want to use that as your backend, you can. If you want to use MongoDB as your backend, you can. It really it's six of one, half dozen the other for a portfolio. Databases and confusion are long term friends. Oh, and Honda Civic posted a sequel murder mystery game. Oh, that would be fun. If you like if you like learning things through games, you might want to check that out. Thank you, Honda Civic. All right. Okay, so in let's post this answer in the Code Wars and actually get some points for it, and then we'll take a break. Oh yeah, and SQL Zoo. That's a great one as well. Yes, I would recommend SQL Bolt, SQL Zoo. So those are more guided tutorials. And again, if you just want a plain a sandbox where you can just throw stuff at the wall and see what sticks, W3 Schools has a pure sandbox environment. Lupo, yeah, I think as Rex said, I believe BigQuery is Google's cloud environment as well. Yeah, yeah. All right, let's pop this into Code Wars. So remember, I put out I deleted the extra lines that we added because they only wanted just all the data and then ordered by employees descending. So let's see. This is what they and I got to select the whole thing and run it. There we go. Okay. So sorted by employees descending. That should be correct. We're going to drop this in. Test it. Yay! It worked. All right. Let's attempt. Yay! It worked. All right. Let's submit. Yeah. Okay, and as you can see, the top answer is exactly the same as what we did. So go us. And then, as this other person has demonstrated, oh, thank you for the follow line.
Lion Bite 7 just followed.
As this other person demonstrated, just as a reminder, you don't have to do select star. You could also explicitly say which columns you want. So this person said select ID, CEO, motto, employees, and then the rest of the query is the same. So you don't have to do select star. You could also specify your columns.
Power Oath just followed.
Thank you, Power. Thank you for the follow. Okay. So there's two different ways to do it. Both are equally valid. Um, the star is kind of just a shorthand. When you know you want all columns, you can just say select star. All right. Now let's find out which one we're going to be doing next, and then we'll take a break. So we'll set up the question. You can think about it. We'll take a 5-minute break, and when we come back, we'll work through the query together. So we did this one, this one. Let's do. Let's look at this one. Yeah, this is a good one. So this one is on the Canadian border. I've never been to Canada. How many of you all have been to Canada? Maybe some of you are from Canada. Anybody from Canada? I don't really have an excuse to not have been there. I live right underneath Canada as their, weird dysfunctional sibling, but just to pass by. All right, so you're a border guard sitting on the Canadian border. You were given a list of travelers who've arrived at your gate today. You know that American, Mexican, and Canadian citizens don't need visas because we're all on the same continent, right? So they can just continue their trips. You don't need to check their passports for visas. You only need to check the passports of citizens of all other countries. Select names and countries of origin of all the travelers, excluding anyone from Canada, Mexico, or the US. And the schema here is going to be name and country. So our table has two columns, one for name, one for country. And the United States is written as USA in the table. All right. So I've already done a select star from travelers to see what the table looks like. We'll run that. And we can see it's pretty straightforward. So we're going to take a break, but I want you all to think about how we could write a select statement that would return the name and country of all travelers, excluding, so that means not including, anyone from Canada, Mexico, or the US. Okay? If you know it, don't put it in chat just yet. Think about it, and we'll build it together when we come back. Okay? Ewan says, can you recommend some database easy to access for front end dev to link to some new project? Something easy, I mean. If you're trying to make a database for a front end project, Supabase is really easy to set up. It's super easy. and you can like edit tables like with a visual editor if you want to, rather than building them with SQL. I found Supabase really easy to work with lots of documentation. So, and it's, yeah, Dan says there's about 1,000 alternative database types, and we'll be here all week. Yeah, there's tons of different database types, but relational and NoSQL databases are the two big ones. Also, Supabase is free for small projects. So all this stuff I built here, this is all free. It's hosted for free. So that helps. All right. So I'm going to put 5 minutes on the clock. Think about this question. Also, too, I'm going to link to the actual Code Wars question if you want to, run some tests in the meantime, but only if you want to. We're going to build it together anyway. So just think, you can think about it, run some tests if you want to, and then we'll build it when we come back. All right. 5 minutes on the clock. Ugh, I want the Google timer, dang it. There we go. All right. I'll see y'all back in 5. Ken says, up next, drop table. No, don't do that. I'll tell you about that when we get back. If you're curious about what drop table means, I'll tell you. All right. So I'll hold you in suspense until we get back from the break. See you back in 5.
A loner wolf just followed.
Thank you for the follow, Loner. Okay, folks, we got about a minute left in the break, so come on back, get yourself a glass of water, get up and stretch. If you've just been sitting down the whole time, get up for a minute if you're able to, and stretch your arms, stretch your legs, roll your wrists, straighten your back. I have a tendency to go gremlin mode when I'm working, and I hunch over. So straighten up if you can. And then come on back when you're ready. Michelle says, where devs gremlin mode is completely normal. Oh, yeah. My poor chair. I'd be a shrimp on my PC chair. All right, I'm gonna stop the timer. I gotta admit, I'm the same way. It's terrible. It's bad for my long term health. Yeah, that's why I stand while I stream, because like if I sat down while I streamed, like that would, I think my back would explode, because I sit down all day at work. I have terrible posture, and then I gotta stand up on the weekends. Kiro says, "I got my first SQL Code Wars point. Let's go! Woo! Good job. Yeah." Yes, and just as a little aside, Dan Can Code mentioned drop table. So yes, there is a keyword. Um, and called drop table, and you can say drop table, for example, travelers, and what that would do, it would completely delete the entire table, which is obviously not something you generally want to do, right? um, so yeah, drop table is one of those things that's very dangerous, because you can delete an entire table's worth of data all at once. So yeah, don't do that unless you've been explicitly told to do so. Luckily, most of the time in databases that you'll have access to, you won't have permission to do that. You will have permission to build select statements against the database, but unless you are the owner of that database, you won't have permission to do things like drop entire tables, because obviously that causes problems when you are actively deleting, entire tables worth of data from an active database. So Rex Rocker says, standing desk at work. No, I have a sit down desk for my work, but this desk that I'm at right now is I'm standing up. Yeah. Drop the whole schema. Come on now. We're trying to start people on the right foot. Don't give them that. I'm kidding. All right, let's build our query. So, select names and countries of origin of all the travelers, including anyone from Canada. Excluding anyone from Canada, Mexico, or the US. Alrighty, let's do it. So we're going to write it out like an English sentence. So give me the name and country of all travelers who are not, I'm going to phrase this a little differently, whose country is not Canada, Mexico, or USA. So I specify USA here because the United States is written as USA in the table. So we can see here in the table, United States of America is written as USA. Okay. So our request is give me the name and country of all travelers whose country is not in Canada, Mexico, USA. I've already done a select star here, but once again, we could also specify the specific column. So we'll say name, country, from travelers. Now, what do you think we need next? If I just run this, it's still going to give me everything. Rex says, do you recommend writing down the instructions as an English sentence as a comment during interviews? If you want to. I think it's just easier when you're learning what the keywords are to do that for starters. I don't know that I would necessarily do that in an interview, not at my level, but maybe for like an introductory SQL interview, you might. Yeah, we're going to need some kind of a where statement, right? We want to filter. We're filtering out certain countries. And so if we want to filter, the keyword that we want is where, exactly. And something to do with country. You're exactly right. Where, and then something about country. Now, what do we want? country is not Canada, Mexico, or USA. Okay, so let's experiment a little bit. Let's experiment a little bit. If I was working with JavaScript and I wanted to say something like a variable was not equal to something, how would I do that? What are some ways that I could do that? Yeah, you might do, and then you might do the exclamation point equal equals, sure. And then what would I put after that? What would I put after the exclamation point equals equals? How would I write the whole rest of that statement if I was saying, all right, I want this variable to be not equal to um, essentially a string or a list of strings? How would I do that in JavaScript? Sure, yeah. You might do not equal, yeah, and then just the name and string, right? And in string format. So um, let's try that. Let's say USA. Okay, look at that. It worked. Huh, isn't that interesting? There's some similarities between how JavaScript and SQL works, right? Some things that translate across, especially when you're talking about comparison expressions. There are some things that translate across. Yeah, and we could do the same thing for Canada or Mexico. And Phil says, "Oh, you're teaching JS too?" Yeah, actually, that's what I normally teach. If you look at the other videos on my channel and my YouTube archive, uh, I primarily teach JavaScript full stack web development. But like I said, I'm a SQL developer in my day job, so doing JavaScript on the weekends is fun for me. It's a fun little difference. Yeah. Okay, so there's some similarities, right? Now, but we don't want just Canada, right? So what's one way that we could also exclude other countries? Uh, Rex, the command is exclamation point YouTube. There you go. Yeah, so we could do it like this, and country not equal USA, and country not equal Mexico. All right, let's try that. Hey, that works, right? That's functional. That works. It's definitely, it gives us the result that we wanted. But doesn't it feel a little repetitive? Maybe a little bit. Seems like we're yeah, exactly. As Kira says, is there a shorter way to do that? Seems a lot to write for three exceptions. Yep. Yep. Yeah, some folks are thinking of maybe some other ways that we could, yeah, can all the items be put in an array or some kind of a list, right? Maybe. So this definitely works. Absolutely. It gives us the result that we are looking for. It's a valid query. However, let's make it a little less repetitive, right? We want to make our code dry. We don't repeat yourself, right? That's what we want to do. So let's revise this a little bit. So this is valid. I'm going to leave this first one up here so we can see the difference. So I'm just going to copy and paste and put another query down here. All right, select name, country from travelers, where country. All right, so somebody suggested where country not in USA, Canada, Mexico. Okay, let's try that. Country not in. Now, instead of an array, I'm going to use standard parentheses. That's just how you do it. So Canada, USA, Mexico. Let's try this. Hey, check it. That's also very similar to JavaScript, right? Except for the fact where you just use a regular list and regular parentheses and not an array. Nice. Yeah, exactly. So just as you all already knew, right? Because you know how to make this simpler in JavaScript. You're all like, isn't there a better way to do that? Can't we put it in a list? Can't we put it in an array? Um, Yes, you absolutely can. So the concepts of filtering in SQL are incredibly similar to JavaScript and incredibly similar to so many other languages. These concepts, once you know one language, the concepts translate between most other programming languages. You just have to know how to write them properly. But the basic logic, the basic concepts, it's pretty much the same across the board. And so that's what we've done here. Now, another way you could say this, you could do the reverse, and you could list all the other countries, like you could list France, Germany, Australia, India, and UK, and you could say we're country in those countries. We're just doing the reverse here because we want to exclude these values. But if you wanted to only include a set of values, you would say we're a country in, and then list the values. Okay. Yeah, and in NoSQL, there are limitations for the types of queries you can write. I think SQL has a bit more flexibility when it comes to that kind of thing. Yep, I agree. Okay, so questions on this. And another way you could write this too, and I'm not trying to confuse anybody, I'm just showing you some options. Um, you could also say not like. That's another keyword you could use, especially if you had like partial strings. So where you wanted like a partial match on a string, you only wanted to match like the first three letters in a string, you would use like. But oh, whoops. Okay, well I guess I can do that in Oracle, but I guess I can't do it here. So we'll do in. It's all good. So use in to check against the list of strings, and not in if you want to exclude from that list. All right, so both of these work. Both of these work, but this one I think is the better option. All right, any questions on this? I would say out of the two answers, we should submit this second one here. I think this is the better answer to submit to Code Wars, but I mean, this one I'm sure would work as well. And like I said before, occasionally you're going to encounter differences in the way things are written between something like Oracle SQL, Postgres, Microsoft SQL, whatever. But in general, they're going to be minor. Just like I mentioned before, in British English, they say crisps. In American English, we say chips. It's the differences are minor. As Kira said, yeah, my first solution was select name country from travelers where not country USA and not country equals Mexico and not country equals Canada. Yeah, exactly. So you could have done it this way as well. You could have said something like, not country equals Canada. Yeah. So this is essentially saying where country equals Canada, not, right? So you can use the not keyword to reverse whatever this statement says to return the opposite. So you could say that as well. But I do think that like using the bang equals, I think that's a little easier to parse. But yeah, you can see it still returns the same result. Sassy query language, exactly. If you want to get sassy with your queries, you can use the not keyword a lot and sound like a valley girl. It's perfectly up to you. This suit is black knot. Yeah, that's what I was thinking too. What is that? Was that Borat or was that one of his other movies? Yeah. So you can see there's options. There's different ways you can write this stuff, and the more ways you're familiar with when you're reading somebody else's SQL code, you'll be able to interpret it. But we're going to use this answer to actually submit into the Code Wars. Sassy query language. I like that. SQL, sassy query language. All right, we're going to train the kata, put in our answer. Oh, yeah. That would be the best answer, Infidel. Hey, we passed. All right, let's attempt it. Hey, we passed. And let's submit it. Let's see what other people did. Exactly. So look at that. Our answer was numero uno. Good job, guys. You all came up. I didn't come up with this answer. You came up with it. You already figured out. You guys already figured out the top answer in Code Wars for a SQL question. And some of y'all didn't even know SQL before you started this stream. So See how quick it is, how quick you can pick up these concepts. Your cross joins are all the rage. I did one of those. I did a cross join once accidentally at my first job, and the database administrator literally hunted me down at my desk. Like, she found me. I was terrified. She was, yeah, man, she was scary. All right, let's see what other people did. Select name country from travelers, where country not in. Yeah, they just ordered. So this is the same answer. They just ordered it differently. Um, that's literally the same thing. They're just sorted differently. This one here did a little extra check. They said select name country from travelers where country is null or country not in Canada, Mexico, USA. So it's entirely possible that maybe in the travelers table, people could have no country listed. The data is not complete. That's a very possible thing. You can have null values in a table. And what does null mean? When I say null, what does it mean? I'm sure you've heard of the word null before, but what does null mean? Yeah, as Kiro says, no entry. So it essentially means there's no data there, right? So it's not like it's an empty string. It's not zero. It literally means there is no data there. Nothing in that column for that row. So what this query is essentially doing is it's just checking to see if there are any null values or if the country is not in Canada, Mexico, USA. So this query would return country values of null and any country that's not in Canada, Mexico, or USA. Yeah. Inferno says, why don't you use Planet Scale instead of Supabase? I've used Supabase before, and I just wanted to build a quick database for these Code Wars problems. I didn't think about it very hard. No particular reason. Dan says, well, wait, so null would not be included in our query version. Yeah, so there's null is handled slightly differently than like an empty string or something like that. So a lot of the times you have to do specific checks for nulls. In this case, the data is fully populated. There's no null values in the table, so it works just fine. But we'll see a little bit more about nulls later on. There's a question later on that deals specifically with nulls. And so we'll talk about that a little bit more in the future. I just thought it was interesting that this person thought about it and did a specific check. So pretty similar. The rest of them are pretty similar. Really, there's not very many different ways you could do this. So we got it right. Go us. All right, let's do another one. Ooh, here's a good one. This is one you've probably done in JavaScript before, but now we're going to do it in SQL. So quarter of the year is what it's called. Look it up and we'll read it. So as you can see, this one's available in a lot of languages. I've already done it in JavaScript. I'm sure you probably have as well. Given a month as an integer from 1 to 12, return to which quarter of the year it belongs as an integer number. So essentially, they give you a month, you return the quarter of the year that it belongs to. For example, month 2 is part of the first quarter, month 6 is part of the second quarter, and month 11 is part of the fourth quarter. Okay. And in particular, with this question in SQL, if we click on train, it tells us what we get. So you are given a table quarter of with column month, and your result should be in a column named res. So we'll talk about how to do that. I'm going to make this more readable here. All right. You are given a table quarter of with a column of month. Return a table with column month and your result in a new column named res. So we're going to have to create a column in our result set. So we want to return the actual month that they give us, and then also return a new column that didn't exist before named res with the quarter of the year that our month belongs to. So, how do we do that? I would get okay. Yeah, hold your guess there, Dan. We'll see. We'll see if it comes close. Rex says, "Do you like code boards over the other platform that offer the same coding challenges?" I assume you're talking about Leet Code. So Leet Code tends to be a little bit more intense. If you're just starting, if you're just learning, if you're just starting and you just want to practice the basics of a language, just JavaScript or SQL, I like Code Wars better because it's less. I don't know. It's less I don't know, alpha about it. Code Wars is more just about like, hey, let's all practice the fundamentals together and not get too crazy. Whereas Leet Code tends to go really hard, really fast. So it just depends on what type of challenge you want. All right, so I've done a select star. We'll run it again, and we can see we're given a list of months. Now we want to essentially take each month and figure out which quarter of the year it belongs to. So distancing ourselves from SQL for a minute, if I was doing this in JavaScript, how might I do it? If I was making it, let's say, a function to check what quarter of the year a month belongs to, I would pass in the month as as an argument to my function, right? But then what would the logic look like? How would I calculate that logic? Dr. Moto says a bunch of if statements. Sure, that's valid. 12 of them. Maybe not that many. How what's a reasonably concise way we could handle this type of operation in JavaScript? Month divided by 4 and round down. Sure, we could do it that way. Chain ternaries. Ah, yeah, that would be a way we could do it. Month divided by 4 as. Oh yeah, we got some really good guesses there. Yes, so those are extremely valid. Yeah, so I'm having us think about it in a language that most folks already know, thinking about it in terms of just the basic logic, and then we'll translate that logic into SQL. Sir, this is a family friendly channel. Nobody wants to chain ternaries on a family friendly channel. Yeah. All right, let's think about this. So, what are we being asked to return? Return a table with column month. So, obviously, that's the first thing we need, right? But then we want to create a new column called res, right? Now, return table with column month and you result in a column called res. So res doesn't currently exist. So if I did a select statement on these two things, I would get an error, invalid SQL query. So we have to create the column called res within our select statements, right? We have to create this brand new column, and we can do that. You can create a new column inside of a select statement, but you need to give it the logic to build that statement. And I'm going to demonstrate how you could create a new column. So I'm just going to say month as res. What I'm doing here is I'm creating a new column called res using the as keyword, and I'm just going to populate it with all the values from month. So let's run. And when I do that, I can see I get two columns back now, one called month, one called res. Res just contains all the values from month, but it's been renamed, given a new name, and a new column is created as res. So this is what's called an alias. You're creating a new column and you're giving it a name. Now, when I do this, did that add the res column to the table quarter of? What do you think? I just created a new column in my result set here called res. If I do just a select, if I just do a select star from quarter of, if I did this and ran it, would I get 2 columns back? What do you think? Yes, and admin, you're right. Star gives you all columns, but I have just done this. I've the original table only had the month column, but then in my select statement, I said I want a new column called res, and I got it back. It's right here. Now, if I do a select against the base table again, will it have both columns in it? Yeah, exactly. Y'all are smart. Y'all know that I have not done anything to change the original table, right? I have created this res column in my results set, but I haven't changed the original table. Yeah, exactly. Y'all are smart. Hey, Arestus, how's it going? Yes. And this is basically like when in JavaScript, when you do a GET request against an API. So select is like GET. It's read only. You're not writing anything back to the database. You're doing a GET request and you're only reading data. Now you can do whatever you want to that data while you're reading it, but you're not changing the original data in any way. So that's just important to remember. All right, now let's figure out how we actually build our res column. We want to do some math here. We want to do some logic, and y'all had some great suggestions of how we can figure that out. So let's. I'm going to go back through the list here. My mommy says I'm smart too. It's good to have positivity. Caretaker suggested month minus 1 divided by 3 plus 1. Wow. I kind of want to see if that works. Caretaker, I'm literally copying what you said. We're going to try it. Do that. I'm not a math person, so I'm just like taking you at your word here. Hey, check it. Okay, 10 in quarter 4, 9 in quarter 3. Is that right? 10, 12, 11, 10. Yeah, that's right. Yeah, that's right. Okay. Quarter 4, 4. Yeah, that's right. That's right. That's right. Yeah, I think that works. Awesome. That was a very nice one-liner Code Warsy solution. Good job, Caretaker. So as you can see, we can do math. We can do mathematical operations and logic directly inside of a select statement, just like we've done here. So it's not just reading data, you can also perform logical operations and create new columns in your results set. So for example, if I was querying a table that had information about, say, I don't know, I'll thank you for the follow, RB. That had information about, say, like customer sales and things, something like that, and I wanted to, you know, see, like, average out by month how many sales a customer was giving me. I could divide their yearly sales by 12 and get a rough average, right? And so you can create as much logic as you want and return as many results as you want from a single query. Okay, now let's look at another way to do this. I just want to, this is not going to be as efficient as what Caretaker provided, but I want to show you another thing that you can do. So another thing that folks suggested was if statements, right? If something is true, then do a thing, else do something else, right? And like I was saying before, those concepts do translate across. You can have if else style logic in SQL queries. So if you have a bunch of comparisons you want to do, if you want to, have, basically, yeah, if you want to do comparison statements and return a true false or whatever, you can do that in a SQL select statement. So we're going to do another select. I'm going to do select month, not month from quarter up. Now, I'm going to have something as res here. if I was doing it in JavaScript, like if I was using the if statements to do this in JavaScript, I would probably say something like, um, thank you for the follow, Dark.
Darksis just followed.
I could say something like, if month less than or equal to, or sorry, yeah, if month less than or equal to 3, then 1, right? Else if month less than or equal to 6, then 2. Else if month less than or equal to 9, then 3. Else month less than or equal to 12, then 4, or just else for. So that's how I could potentially do it in JavaScript if I wanted to write it out in a little bit longer fashion. Um, that's kind of a lot of if else, though, right? What's another way in JavaScript that I could do a statement like that where I'm doing a bunch of comparisons in a very long list? If I had a long list of comparisons that I wanted to do, what would be a better way to do that in JavaScript? What other type of statement might we use? Yeah, we would use a switch statement, right? Switch statement. And if y'all have paid attention to my streams before when I'm doing JavaScript projects, you know I've said before that I love switch statements or case statements. Now you're going to find out why. Even though nobody else likes them, I do. Because that's how you do multiple comparisons. That's basically how you do an if else statement in a SQL query is you have to use a case statement or a switch statement. So alternatively, I could say case when month less than or equal to, what is it, 3, then 1. And just like we said before, this equals 6, then 2. Less than or equal to 9, then 3. And then I could just say else 12 end as res. Let me see if I did this right. I don't normally get it right the first try. Let's see if I get it right. I did. Oh, yay, go me. Yes, and you don't have to worry about, oh, sorry, yes, sorry, else for. My bad. I wrote that wrong. Yes, my apologies. Okay, there we go. That's better. 10 for, yep, that's right. Yes, and so you don't have to worry about break statements, unlike JavaScript. Case statements in SQL don't require break. Um, you can just say case when number 1, number 2, number 3, else, and then you can have an else statement at the end. And then at the very end, what you need is the keyword end. So that tells SQL that you're done with your case statement. So end, and then what do you end as? Res. That gives you the same result. Now, in this specific case, it was much faster for us to just do it as a mathematical equation, right? To just do some basic math. However, I think it's important that you know how to, or that you can recognize what this is, that essentially this is an if else statement, except in SQL form. It's doing the same thing that an if else statement would do, except this is how you write it inside of a select statement in SQL. Okay? Power of Dot says, is indentation important? No. That's really just to make it look better. SQL does not care about indentation or white space. So you could put things on a single line. You could really go crazy with this. I mean, you could do whatever the hell you want with spacing. You can indent things all the way across the page. It's kind of like JavaScript. It doesn't care. As long as you have things in the right order, it's going to be able to interpret it. So that's a great question. But generally, for things like case statements, you saw I indented those automatically because that's what I always do. It just makes it easier to read, kind of like you would do for an if-else statement in JavaScript. You would indent things inside of it. There we go. So you see, it still works with the indentations. Drunken Grandma says, "Why is it else instead of default?" Just how it is, you know. It's again, it's the British English versus American English thing. Things that are just, just how you write it. So it's kind of a weird hybrid of like an if else statement and a switch statement, right? It's got, the keywords from a switch statement, and then the else from an if else. So a little funky, but this is just important to know that, someday you'll be doing a query and you'll be like, hey, I want to have some if else logic in here. How do I do that? Oh yeah, I need to use a case statement, and that's how you do it. Yes. Hey, welcome, Oais. We have not done joins yet. Hopefully, we'll get to one of those a little bit later on today. Right now, we're just focusing on the basics of how you structure select statements and how you build select statements. Um, so I think of the two, we'll go ahead and submit the shorter one because that's how Code Wars is. They like short things. So we'll submit this one. Thanks again, Caretaker, for that logic. Um, let's submit it and see if it works. Yay! All right, let's attempt it. Hey! And let's submit it. All right. And I thought this one would be interesting because there's a ton of different possible ways to do this. I've showed you two of those ways, and that's kind of what we see here. So the first way is just doing it as like a math problem, right? The second one is using a case statement. Case when, and as whatever. Oh Lord, indeed. And then you also, so this was the other suggestion from chat, which was doing things as, a floor or a ceiling, doing some rounding up or rounding down. So that's what this person has done here. They've used some more advanced keywords to do that kind of mathematical rounding. Here's another case statement. I don't know what that person's getting real weird with it. And here's the solution that we came up with. And then this was let's see. And this person has also done a case statement, but they use that in operator that we talked about before. We previously saw the in operator. They said case when month in 1, 2, or 3, then 1, month in 4, 5, and 6, then 2, month in 7, 8, 9, then 3, else 4, and as res. So kind of combining some of the things that we have looked at previously in the previous questions. But yeah, so oftentimes with SQL, just like with JavaScript, there's more than one way to get at the answer that you want. Whatever the right answer is really depends on number one, how your employer wants you to write code. Number two, efficiency. So especially when you're working with larger tables. So when you're working with a very large table, you can always experiment and run your query a couple different ways. See which one returns faster on average. Most SQL clients will have some kind of a timer that times the execution time of your query. And so you can see usually somewhere at the bottom of the screen, hey, your query took 10 milliseconds to execute. Hey, your query took 2 seconds to execute. Hey, your query took 30 seconds to execute. And you can see, hey, is there a way I could write this more efficiently so that it executes more quickly? It just sometimes there's a little trial and error. All right. Any questions on this one? Once again, both of these ways of doing it are equally valid, just different. All right. And again, feel free to ask questions at any time. I think let's do. So how do we visualize it? Like in terms of efficiency? Because let's say we had 10,000 rows. What will this query do? Because in data structures, we have big O notation. So yeah, most SQL clients will have tools that can help you with that. So there'll be certain like built-in database queries that you can run that will show you execution times and efficiencies. And some clients even have built-in tools that are going to help you give you performance suggestions for very large queries. So yeah, most clients will have some kind of a built-in tool or query or something to help you visualize performance, generally execution time, execution efficiency, resources used, memory usage, that kind of thing. So in general, with SQL queries, it's all about, okay, how much of the computational resources is this query requiring? Like how much memory is this query requiring to execute? How much time does it take? Um, those are kind of the big considerations with queries, because you want to make sure that your query isn't hogging all the resources in the database and not letting anybody else run queries. Hence, what I mentioned before, when one time I ran a cross join, which is a very resource intensive query, and a database administrator literally hunted me down at my desk to tell me to never do that again. Thank you very much. Um, yeah, resources are important. S1 says, "Hi, is it what a SQL dev does to check the best query to apply?" That's part of it. Yeah. That applies to pretty much anybody who uses a database, though. It could be uh, data analysts use SQL databases a lot of the time. They write in SQL. I started my career at being a data analyst. So I was not a developer, but I wrote queries against SQL databases to get data to analyze. Um, so that's really the duty of anybody who writes large queries against the database, not just developers. As a developer, what I do is I build the objects that people write queries against. So, for example, see all these queries up here, the ones that say generate. This is where I built the tables that we are querying against right here. So, for example, this quarter of table that we just queried against, I built that yesterday. It's right somewhere here. So I built this yesterday using SQL. So as a developer, you're not just reading things, you're also creating new things, right? Creating new tables, creating new database objects, creating new views. Um, and also as a developer, I build data pipelines that feed data into database tables. So automated systems take in data all the time. For example, the cash register at the grocery store. Every time you check out at the grocery store, um, you complete a transaction, right? You've bought 6 items. They scan your membership ID for the grocery store. You scan 6 items, you get a total. That is a transaction, and that data is being captured by the cash register and then stored in a database somewhere. But that requires a pipeline from the cash register to the database, right? To store that data. Somebody's got to build it. So I build those types of pipelines and the tables where that data gets stored. And then other people, such as analysts, will write queries against that data. And just like we've been doing this whole time, write statements against it. So that's kind of the difference. Oasis says, "Are you talking about ORMs like in Laravel?" Not necessarily. I guess. Well, I guess so. I'm trying to. It's so building data pipelines is kind of is um, called ETL. It has a very specific name. It means extract, transform, load. That's where you extract data from a source, you transform it, make it ready for the database, and then you load it into the database. And so that's called ETL pipeline generation. And there's a lot of different tools you can use to do that. ORMs are more like ways that you talk to a database, where ETL is a very specific type of data transfer. Yeah, exactly. As Dan says, ORMs are what you'd use if you didn't have an actual SQL dev on your team. Um, what ORMs allow you to do is to talk to a database via a more user-friendly platform, such as using JavaScript to talk to a SQL database. Whereas if you know SQL, you don't have to have an ORM. You can just talk to the database directly. S1 says, "Thank you for the explanation. I don't see the difference between this and a backend dev. Is SQL dev some kind of specialization?" Yes. SQL devs write SQL. Not all backend is going to be written in SQL. Some backends may be MongoDB, which doesn't use SQL. It's literally a NoSQL database. Some backend devs don't work with databases. Maybe they just write APIs, right? Backend is more than just the database. Backend is also servers, APIs, that kind of thing. So there's all sorts of specializations. Backend dev is a I would consider myself a backend dev, but specifically I'm a SQL dev. So backend is kind of like an umbrella, right? under which under which a lot of different categories can fall. So when I build an API, I would say I'm working in the back end. When I write SQL, I'm working in the back end. But specifically, what I get paid for during the day is to be a SQL developer, writing SQL code. I hope that makes sense.
Michelle_2 co just followed.
And in tech, I find that we tend to throw a lot of terms around, and sometimes they mean what they say they mean, and sometimes they don't, and meanings shift over time, right? So, you know, I never get too hung up on terminology. As Rex said, so you're like a data engineer? I guess. Yeah. I mean, I guess I build, I engineer data. Oh, yeah. No, SQL developers are big. That's a huge category in the job market because most databases are SQL based. Um, most of them are SQL based. Most of them are not like MongoDB or something like that. Most of them are relational databases. Um, yep. Oh, third decade. I'm sorry. Did I miss a question? Oh, third decade says, if you have a massive database of information, how does a SQL developer verify that all the inputs are correct? So that's a great question. I love that you asked it. So SQL is a little bit different than MongoDB. So with MongoDB, just like JavaScript, MongoDB really doesn't care what you put in it, right?
Calvin
Thank you for the follow,
_1
Calvin.
from just followed.
MongoDB gives no craps about what you put in it. You could change your schema, you could write it in the same collection. MongoDB doesn't care, right? It's going to take whatever you give it. How you control that input with MongoDB is you build mongoose schemas, right? You build a mongoose schema to validate your data before it goes into the database and make sure it's correct because MongoDB don't care. SQL databases, relational databases are very, very different. The database itself, just as Dan said, the database itself validates your input and it will not allow you to write things that don't belong. It simply won't let you. And you might ask, why is that? Why the difference? Well, I'll show you. Let's see, that's a bad example. Here we go. This is a better example. This is a table for another question that we haven't seen yet. But look at this. Look what happens when I create this table directly in the database. I'm creating a new table called students. Look at the type of things that I have to specify. I have to specify not only the column names, name, age, semester, mentor, tuition, but also their types, right? I have to do that first. Before I write any data, I have to build the table and specify every single column type. And if I try to write something into that table that isn't that type, if I try to write a varchar or a string,
S1
oh, thank you
just
for follow us,
followed.
fine. If I try to write a string into the age column that's expecting an integer, I am going to get an error, and the database is not going to be happy. It simply won't let me do it. And that's probably one of the biggest differences in behavior between something like a MongoDB database or a document-based database and a relational database, is that relational databases are type specific. They require the right type in the right place. Data types, baby. Exactly, Mattel. Rex says, "Will you doing any API workshop soon? I don't want to miss it." Yeah, we build a lot of times on my streams. We build full stack projects. If you want to see, I have a ton of recordings of full stack project builds where we build APIs and things on my YouTube channel. You can do !YouTube if you want to see some of my past streams and build some full stack projects yourself. D-Rock says you can add many types of SQL database constraints and rules for data tables too. Yeah, you can get as strict as you want, really. Yeah, you can set a bunch of rules, and those rules are applied directly to the database. It's not with something like MongoDB. You're validating inside of your own application, right? You have a schema set up inside of your app, which then filters the data that actually gets written to the database. So any app that is writing data to that database needs to have the same filters inside of it, right? It needs to have the same schema. So with a MongoDB database, you could end up writing bad data if an app didn't have those filters and was trying to write to your database. That's not the case with a relational database because the filters are at the database level. It's not going to let you write bad data no matter how hard you try. You will get an error. And that's one of my favorite things about relational databases is that they are strict. They are type specific. So I hope that makes sense. Yeah, baby. Yeah. Good. All right, let's get another question going here. Oh, and before we get off of this, so here you can see I created the table. And then this is just a little taste of how we would insert data into that table. So first you just create the table structure and then you insert the data. So it's very simple. It's called an insert statement. You just say, hey, these are the columns I'm inserting, and then these are the values that I'm putting in those columns. So we'll get a chance to practice that later on. I'm just giving you a little taste of it there. Dr. Mona says, we doing any migrations? No, not today, certainly. All right, let's find a good one. Next one here. I want to do counting and grouping next, I think. Yeah. Okay, so next one we're going to do is called counting and grouping. Hey, Sushi, welcome. So let's find that question. We'll read through it. This one introduces another really important fundamental concept of writing basic SQL queries. Oh, come on, counting your. Oh, maybe that's a 7Q, but it's a very important concept, so that's why we're doing it. Come on, there we go. All right, we're given a demographics table in the following format. It's got the columns ID, name, birthday, and race. You need to return a table that shows a count of each race represented, a count of each race represented, so each one that's in the table, ordered by the count in descending order as 2 columns, race and count. Okay, so they're asking for 2 things here. They want an order, right? They want us to sort it in a particular order. We know how to do that. But they want us to count it. So there's going to be repetition, like multiple people are going to be, I don't know, African American or whatever. And what they want is essentially just a table with 1 row for each race and then the count of people who are a member of that race in the second column. So that's a little extra layer, right? So let's see how to do that. Let's think about how we might do that. Counting and grouping. Here we go. All right, so here's what our table looks like. And we can see we've got an ID value, we've got their name, we've got their birthday, and we've got their race. And what they want in the end is just 2 results, one column for race, 1 column for count. So what we would do is we would have, let's say, Caucasian, and then the count for that would be 1, 2, 3, 4, right? Caucasian and 4. We would have Hispanic would be 1, 2, so count of 2 for that. So what we're going to have to do somehow is collapse this table down so there's only 1 row for each race and a count of the number of people that belong to that race. All right? So let's write the question out in plain English. Give me a single row for each race and the count of people who belong to, I'm going to put this on a new line so you can read it, that race. from the, what's that table called? Demographics table. And they want it to be ordered by the count in descending order. Ordered by the count descending. Okay, so they're asking for several things here.
Dobler just followed.
Oh, Dobler, thank you so much for the follow. So there's a few things that we already know how to do, right? We know how to put things in a certain order using the order by clause. So we're probably going to have to use that. So we'll go ahead and add that to the query. So if I wanted to, I haven't done anything else yet, but if I wanted to, let's do the two easy parts. We know that they want this column returned, right? And we know that they want a order on something. So we can start building the query. How would I return, just for now, let's just return the race column. How would I do that? I don't want to return these other columns. I just want to return this column. What would my query be? Yeah, I would specify just the column that I want, right? Okay. Yeah, that's how I would do that. Exactly. So that's a start. And we could do something like order by race as well, right? That's not quite what the question is asking for, but let's just test it out. Yeah, and so that just orders by alphabetical order. Okay. And then what would I need to do in order to order by something in descending order? So let's say I wanted to order this column in reverse alphabetical order. What would I do? Yeah, I need the descending keyword. Exactly. Okay. And we saw earlier that descending works for count, right? But it also works for alphabetical columns. Yeah. ChatGPT, how to order by descending. So this is, yeah, no, you not, that's not an oops, Rex. We're gonna get that. We're gonna get the count going. I'm just reminding us what keywords we need. So we saw earlier that this order by statement works for numbers, but just FYI, it also works for like strings too. It also works for alphabetical stuff too. It puts things in alphabetical order or alphabetical order descending. All right. So this is a start, but we're missing this second element here. We're missing the count of people who belong to a particular race. And we also want to make sure that we only have one row for each race. So we're going to take a break for 5 minutes. And when we get back, we're going to learn how to build this so that we reduce this, we get rid of any duplicates, and we have a count of whoa, cliffhanger, and we have a count of the number of people who belong to that particular race. So group by and count are two very important things when you're writing SQL queries and doing analysis on data in a database. So very important concepts. So 5 minutes on the clock. Also important when you're building apps from this kind of thing too, because if you think about it, you're going to want to have, in your app, you're probably going to want to have, maybe number, if you're building an e-commerce app, you might want to have number of previous orders or count of previous orders for a particular user, right? You might want to have things like total of all purchases, right? Previous total purchases, or I don't know, the total that they've saved ever since they've been a member of your awesome app. How much money have they saved throughout their entire, through all the transactions they've made? How much was the total of the money that they've saved? And so that's the type of thing we're going to learn how to do with this particular question. How do we take individual rows or individual transactions and consolidate them down into a single row, which gives us data that we want? Yeah, those types of mathematical operators. Sum, count, average, median, mode, that kind of thing. Power of dot. Let me give you the command for the Discord. There you go. Dan says, let's bring it into JavaScript and use reduce. It's very easy to do in SQL. I'm going to show you how. All right, 5 minutes on the clock. When we get back, count and group by. All right, see you in 5. Okay, folks, we got about a minute left in the break, so come on back, get yourself a glass of water, stretch, get up and stretch if you've just been sitting there the entire time, scrolling through YouTube on your phone or Reddit or whatever. Get up and stretch for a minute. During the breaks, I actually go and sit down for a minute because I'm standing the entire time. So just do whatever the opposite is of what you were currently doing for a few minutes, and gotta confuse your body. Keep it moving. All right, I'm gonna stop the timer and we're gonna go do it to it. I'm gonna answer this question. All right, I turn my webcam back on. 2 seconds. There we go. All right, welcome back, folks. Let's get back to it. Um, so, what are we? Let's remind ourselves what we want. We want a single row for each race and the count of people who belong to that race from the demographics table, ordered by the descending count. Okay, so clearly this isn't quite right. We're selecting race, but we also need a new column. And what did they want that column called? Count. All right, new column was called count. So we're going to have a new column, something as count, right? We already saw it's going to be, something as count, because that's how we create a new column. Right? That's how we alias a column, is we just say as and then whatever we want that column name to be. So now we need to figure out what goes in the something. And then we're going to be ordering as, by that count eventually. So if we wanted to get the count of something, what keyword do you think we might use? Don't think too hard about it. Remember, SQL's meant to read like English and write like English. So what keyword do you think we might use? What keyword do you think we might use? Well, I would say that's a pretty good guess. I mean, and Rex said it earlier, and Sushi, you just said it now. I think count sounds like a pretty good keyword. Are we counting? Are we? We are actually we're counting. So it's not a sum; it's a count. We want to count the number of rows or the number of people that belong to each race. So not a sum; it's a count. There is a difference between the two. So we're going to count something. So it's going to go through. It's literally going to count 1, 2, 3 people belong to this. 1, 2, 3, 1, 2, 3, 1, 2, 3. So what do we want to count? We have to count something. And we can talk about the difference between count and sum in a little bit. But so let's look at the base table again and see what things we have in there that we could possibly count. So look at the base table again. What's something unique that might be a good column to choose as our counter? So it's for each value it finds, it's going to go 1, 2, 3, 4, and literally count up. What would be the thing that we could count? Yeah, ID seems like a pretty good thing to count. So why don't we do count ID, and then that'll be in a new column called count from demographics. And then we're going to order, we also want to order by that count. So that's what they wanted, right? The count of people who belong to that race ordered by that count descending. So let's see if we can run this. Let's see if this will work. We're going to, for each ID that our statement encounters, it's going to count up by 1. Let's see if we can run this. Let's see if, I'm not sure it'll work, but let's see. Frankly says, nah. Well, let's try it. Yeah. Okay. I wanted to show you this error because it's telling us what's missing. We're missing one more thing, but we're close. We're missing one more thing, and the error is telling us the problem. It says failed to run SQL query. Column demographics.race must appear in the group by clause or be used in an aggregate function. Okay. So it's literally telling us what's missing. So what do you think we need to add to our query? I'm circling it with my mouse. Don't think too hard. Yes, exactly. Group by, group by. Yes. Group by race. And you might be like, what the frick is group by? Well, once I run it, it'll make more sense. There we go. All right, so what is this doing? Well, we're still selecting the value of race, and we're counting, or we're getting the count of IDs of the people that belong to that race. So everybody who has a race value of Caucasian is getting counted. 1, 2, 3, 4. Okay, it's looking at the ID value. It's counting 1, 2, 3, 4 rows have a race value of Caucasian. 1, 2 have a value of Asian. 2 have a value of African American. 2 have a value of Hispanic. When you're using count, you need to tell the query what you're aggregating on. So what is the value that we care about? What are we adding up to? What are we counting up to? Well, we're counting for each value of race. So we group the counted values per race. We group by race. Okay? So this just shows what are we aggregating up to? Well, we're aggregating up to each value of race. Yeah. For the unique entries for the unique entries in the race column, we're aggregating up to them and counting each value that fits in each bucket. Yeah. And so there's some questions about why are we counting by ID? And that's mostly just because I want to demonstrate something, but we could also do something like this. It's really just counting rows. We could also just do count star and count, all right, how many rows belong in each race bucket. So we could also do this. This would work as well. Yeah, see, we get the same result. No, you're not dumb. You're not dumb. This is the count and group by stuff is a little. This is the first part of SQL that's a little hard to get your head around because you have to think in more abstract terms. So basically, you have to think, okay, what are we counting? Well, we're counting essentially just the number of rows that fit in each bucket. And what are our buckets? Well, our buckets are the race column. This is our bucket. And so just like with a bucket, you would take things and put them in the bucket, right? If you want, you know, a bucket for each race and you want to see how many things are in the bucket, then that's what you group by. You group things in the bucket and then that's what you present at the end. Right? So group by, what are our buckets? We group by race and then we order by our descending count. And once again, notice my order that I put things in here. Group by comes before order by. Order by pretty much always goes last. And if you do it wrong, you'll get an error. It'll tell you, you know, oh, I can't execute this. And you just change the order and you'll be fine. So order by is generally always last. It's behind where, it's behind, you know, pretty much all your other keywords. Yes, and it does, in this case, it does still work. Yeah, yep. We have a count star up here and we're ordering by count ID here because in this case, it's 6 of one, half a dozen of the other. I can count individual ID values and I still get four IDs that belong to the Caucasian race. I could count whole rows and I still come up with a value of 4. I still come up with a count of 4. It's 6 of one, half a dozen of the other. So it works. Um, what would happen if you did a group by ID instead of group by race? Yeah, let's do it. There's nothing wrong with doing that. Let's get funky. Yeah, so it doesn't like that because I'm doing a select here and then trying to group by something different. So when you have a count in your query, you need to specify both the bucket and the thing you are counting. And then you group by whatever bucket you're putting things in. So there's a certain structure that goes into it. You can't specify something in your select and then group by something different. That doesn't work. However, we could do this. We could say select ID and then group by ID also. Let's try that. Oh, still doesn't work. Okay, still doesn't like it. And I think it's because I'm doing the group by and the count on the same thing. Let's try this. I'm getting a little weird here. I would never write a group by statement this way. Yeah, still not going to work. Okay. Now we can try semicolon. Maybe that'll work. Oh yeah, that worked. Okay. It was because it was because I was trying to I didn't I was trying it was trying to run two things at once and you can't do that. So I had to just select this specific query. Yeah. So now look what it did. When I chose ID as my bucket and then counted, okay, how many rows belong to each ID bucket? For every single ID value, it returns a count of one because there is only one row for each ID, right? These IDs are unique. So only one row belongs to each ID. Drunko Garema says, not understanding how count star works, does it automatically reference unique key or foreign key? No. It will, if you do a count star, it's going to count the whole row, not individual fields. It's just going to look at the whole row and say, and count a single entire row as one. Yeah. Frankly says, so second count on row is header and a variable or both. No, it's just the value inside of that row. So the header is what we call a column, and these are rows. So each of these horizontal stripes here, that is a row. Neurotical Zena says, so count one count but different IDs. Correct. Let's break it down again. So select ID. This means that each individual unique ID is going to be a bucket. We think about it, each individual ID is going to be a bucket or a toaster or however you want to think of it. Then what we're saying is we want to count how many rows fit in each of those ID buckets. So how many rows have an ID of 4 in our table? How many rows have an ID of 4? 1. How many rows have an ID of 10? 1. How many rows have an ID of 6? 1. 2, 9, 7. All of them have an ID of 1 because IDs are unique. Yeah, it's the toasters. There you go. Okay, now let's put it back. Let's do. We're going to go back here and we're gonna review it again. Group by race. Let's look at this again the same way. All right. How many rows have a race of Caucasian? 4. How many rows have a race of Asian? 2. How many rows have a race of African American? 2. How many have a race of Hispanic? 2. Now, it's the same thing as if I were to use the ID value here in my count. How many IDs have a race of Caucasian? 4. How many IDs have a race of Asian? 2. How many IDs have a race of African American? 2. How many IDs have a race of Hispanic? 2. Same diff. Now, some folks asked earlier, why wouldn't we use sum? Why wouldn't we use sum? Let's try it. Let's see what do you think we're going to get? What do you think we're going to get if I say sum ID as, we'll call it something different. We'll call it sum. And we're going to order by sum. I'm going to change my values across the board here. What do you think we're going to get? Any guesses? If we're not sure, I'll just run it and we'll see what happens. Ah, yeah. Copperly said, wouldn't it just add the values of the IDs? Let's see. Oh, goodness. Yes, you guys guessed it right. Sum and count are two different things. Sum actually looks at the value. So a value, something with an ID of 2, okay, that's a 2. And then it's going to sum it with the next one, which is a 3, and that equals 5. So you have to be really careful whether you use count or sum depending on what you actually want. Do you want to sum the values themselves or just count how many values there are? Ah, it's clicking. Yeah. Oh, wait, you want to try sum star? We can try sum star. Now, remember that SQL is type specific. It's strict. So let's see what happens. Oh no. Here it even says that it couldn't even tell what we were trying to do. Yeah. Because remember, SQL is type specific. So if I try to run a sum on data that isn't actually numbers, SQL is not going to like that. And here, if we do a sum star, it's going to try to sum all this non-numeric stuff. So if you're doing a sum, you better be summing on a numeric column, something that is actually numbers. It could be decimals, it could be integers, whatever, but it has to be a number. Muckalek says, so the IDs are actually numbers and not text. Correct. And I can show you the base table for this, which is demographics. So, yep. In demographics, the ID value is an integer. It's a number. Okay? Everything else is not. Everything else is a string or a date, something different. Engineer Moore says, so no type coercion in SQL? Absolutely not. SQL is a language that is from the 1970s, and it's like your grandfather. It is strict as hell. Uh, yeah, you ain't doing no type coercion in SQL. It ain't about that life. SQL is extremely strict, and even for things like dates, even if you like type in a date value that's formatted as a date in something like Oracle, you actually have to convert it to a date anyway. Even if you type it in like with the same format as what's already in the table, like I type in like, 08 08 2023, like with the slashes in between, I use the same format, type that in. Even if you use the same format, you then still have to explicitly convert it to a date first. Otherwise, Oracle won't accept it. And so, silly grandpa. Yeah. So it's extremely strict. Um, and yeah, you ain't getting away with none of that whippersnapper JavaScript nonsense in SQL. You're saying in SQL, 1 plus 1 is not 11? Well, yeah, it just depends. You can concatenate. You can do things like concatenating strings and things like that. But um, yeah, it's not going to let you add a string to a number. Grandpa never did like to type version. Stubborn old man. Muckaluk says, what way does it store dates? American, European, or international? That partially depends on what flavor of SQL you're using. Some will store it as dates, some will store it as date time. You can, I believe that the actual way that the date is stored is set like at the database level. I think that's like a global configuration that you could do. Or you can also convert things to a specific date type within the table itself. There's lots of different ways you can do that. So, for example, my job in Oracle, automatically all dates are stored as date time. So date plus a timestamp. So I have to do conversion all the time to get things down to just month, day, year, and that I have to convert them explicitly to the American format, which is month, month, day, day, year, 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 year. Like I have to do that explicit conversion. Yeah. Knucklehead says, "I force everyone at work to use year, month, day, day." Yeah, some of it just depends on how your employer wants to store things. So, for example, also at my work, we get data from a lot of external systems. Some of those systems are set to UTC. Some of them are set to I don't know GMT. Some of them are set to Eastern time. Um,
just followed.
Thank you for the follow, Beto. So we get dates coming in that are set to all different time zones, and then um, we generally have to do global conversions to try to standardize them as much as we can. Frankly, yeah, and you said phrase is too fuzzy to use in databases since there's loads of mixed race hosts. Absolutely. And to be clear, the only reason we're talking about this is because we're answering a code wars question. So this is a very specific code wars question that we're using. Race is generally not accessible, or race is stored in databases generally, but it's not an accessible field or widely viewable field. A lot of the times it's locked behind user roles and restrictions. So Yeah, to be clear, we are answering a very specific Code Wars question here. For that's we're not just I didn't just pick this on a whim. All right, let's try and let's answer this question. Yeah, counting and grouping. Here we go. Woo! All right, we're gonna put this back to be correct again.
Minus 12 just followed.
Count. Select race. Count from demographics. Oh, thank you for the follow, Manhas. Group by race. Order by count. Run. There we go. I think that's right. All right, let's see if it works. I'm curious to see. Oops. I'm curious to see how other people solve this as well. Hooray! Let's attempt it. Hooray! We did it! Go us! Everybody clap. No, kidding. This was a harder one though, right? It's a new concept, something a bit different.
Lookalike 2 just followed.
We've completed our mini census data analysis. Yeah, this is so knowing how to use count and group by is really one of the fundamentals of data analysis. Like I mentioned before, count and group by are extremely important and very fundamental if you ever do any kind of data analysis. Thank you for the follow, Muckalek and Dogan. So you got to know how to do this stuff if you want to analyze your data. And to be clear, you could just do a select star and pull down all the data and put it into something like Excel and do a pivot table on it, right? You absolutely could do that. But what if your table had 6 million rows? Would you really want to pull down all 6 million rows? Why wouldn't you want to instead aggregate your data first and then pull it down when you've got it down to like 200,000 rows, right? So that's kind of the main advantage of SQL is that you can pre-filter and aggregate your data before you pull it out of the database at all. So it's already pre-filtered, it's pre-aggregated, it's pre-sorted, and then whatever program you're pulling it into has a much easier time dealing with that data because it's already just a subset and only what the program needs. All right, we'll submit it. All right, so yep, they did a count on race, which is fine because again, it's just counting the rows, the values in that row. So 1, 2, 3, 4, 1, 2, 1, 2. And this is we did ours. This is basically how we did ours. This person here did a little bit differently. They just said select race, count 1. So here, what it did is for every row it encountered, it just entered a count of 1. So 1, 2, 3, 4. You could do it that way as well. I don't normally do that, but you can. And so, yeah, a lot of them are pretty similar to how we did it. And Muckaluk says Excel has a limit of about 1.6 million rows. Yeah. And as a data analyst, that's a really common thing that you encounter. You will always have data sets that are larger than what something like Excel can handle, or other data analysis tools. That you're going to have massive data sets that are much, much, much larger, and you need to pre-filter them in some way before they get into your software, whether it's Excel or something else. And SQL is really the best way to do that, to pre-filter that data. The same with your app, right? Think about your application. So think about how, let's pause for a second and talk about this. So in MongoDB, you store data in individual documents, right? And over time, you might want to keep adding features to your app, more and more and more and more and more features. And so that means that your individual documents are going to have more and more and more fields, right? They're going to have more key value pairs, more things that you need to store. For example, you might have, like for every single post on your social media app, you could have an ID value, the post title, the post content, the post author, you know, whether it's been favorited by other people, whether it's viewable by other people, who it's viewable by, how many comments it has, a link to the IDs of those comments. you're adding fields and you're making documents, huge documents over time. In your app, you're going to have to pull back all of that document data every single time, and then filter it down in your controllers, right? Only grab specific fields or whatever. And so one thing that's nice about SQL is that you can do these queries, pre-filter your data before you pull it back, and only get the data that you need. So that's just something to consider. Wrench asks, what website is this? This is called Supabase, and basically it's just a PostgreSQL database. And what I've done is I've built a database of Code Wars questions and tables so that we can, look at the questions and build queries for each of those questions. So it's called Supabase, and it's just supabase.com if you want to check it out. I found it really easy to use, really quickly. Could quickly build a database. I spent I don't know, 2 hours on this yesterday, just building the database and getting it ready to go. Junko from Grandma says BRB adding pre-filter and aggregate data keywords to resume. Yeah, I added SQL to my resume when I really only knew how to do select and where clauses, like select clauses, where clauses, order by clauses. So basically everything that I've taught you today, I added SQL to my resume when I only knew how to do those things, and it really jump started my career. Once I knew how to do those things, the world opened up as far as data analytics, and eventually becoming a dev. So there you go. Dan says JavaScript probably doesn't like 1.6 million object arrays, especially when you start spreading them around. Yeah, exactly. That's why if you can pre-filter your data, you want to do that.
A Rouse just followed.
Oh, you're Rouse. You're Rouse. Thank you for the follow. Wrench asks, is there a website where we can practice SQL-like questions in LeetCode and HackerRank? Yeah, that's what we're doing here. We're actually using Code Wars to get the questions that we're answering. We're doing them in Code Wars, and then we're actually testing them out in Supabase. So yeah, if you want to practice SQL, and you want to make it in kind of like a LeetCode style format, I would use Code Wars. It's great for the basics. Thank you for the follows, guys. Wow, thank you, Laurie. Yeah, Supabase is very fun to say as well. I always get that that song stuck in my head. Boom, ba doom, boom, boom, ba doom, boom, bass. Got the Supabase. Yeah, so that's fun too.
Just followed.
Thank you for the follow. All right, let's do another one. We still got some time. Counting and grouping. I want to do distinct. Where I have one for distinct here as well. Yes. What? Creodite.
5 subscriptions to the community.
Thank you so much. My goodness. We had somebody who gifted subscriptions earlier on too. Y'all are nuts. Thank you so much for the gifted subs. If you just received a gifted sub from Creodite, please do thank them. Also, now if you are a sub now, you have access to my custom emotes from my channel, which are, in my opinion, very adorable. So feel free to use those at at your pleasure. Yeah, super fun. Thank you so much, Creodite. I really appreciate it. It's so kind. Also, again, thank you to the anonymous gifter who gave subs earlier in the stream. I don't know who you are, but thank you. Y'all are the best. That's why I love my chat. Y'all are always so wholesome. I mean, honestly, how are you all so so cool and nice? I don't believe it. It's great. All right, let's do the next one here. Simple distinct. Okay. Probably Supabase gifted those subs. Hey, I would love if I could get a corporate sponsor, that would be pretty rad. Like a corporate sponsor that didn't suck, like that. It would need like I really like Leon's rules for sponsors, in which they always like any sponsor has to be cool and also offer their product for free and have like a free tier. So Supabase has a free tier. So Supabase, if you're listening and you want to, sponsor me, I'd be chill with that because you have a free hosting tier that people don't have to pay money for. So I'd be cool with that. All right, this is called Distinct. Supabase DevRels are very active on Twitter. Yeah, I'll have to send him a DM. What if a plumber wanted to sponsor you? I'm not sure why they would. I don't feel like you know, might not be the best use of their
Matthew
sponsor money.
Osispo is just followed.
Oh, thank you for the follow, Devma. I thought this whole time Twitch was for gamers only until I found this stream. Oh, thank you, Power. Yeah. So, Power, there's a whole category on Twitch for software and game development, and there's a ton of great content creators out there. Speaking of which, I want to give a quick shout out to another awesome streamer. Um, Hello, it's Rufio, my fellow stream team member. They're great. They are super wholesome. They do a lot of very chill, sort of like hangout style coding content. Also, they just recently told me that they have started using SQL at their job, and they used my intro to SQL stream that I did like 6 months ago. They used that stream to get their skills up so that they could start using SQL at their dev job, which I thought was freaking cool. So yeah, it's useful no matter where you're employed. They are good people, absolutely. All right, let's do another question. We got time for one more here. So for this challenge, you need to create a simple distinct statement. You want to find all the unique ages. So we have a people table. It has ID, name, and age. And what they want to return is just a single column with all of the distinct ages in the table. So let's see what we got. We'll do our select star and just see what's in the table first. All right. So we've got ages here, and actually, I think when I built this, I wasn't thinking. I don't see any duplicates here, but what they want us to return is just really a list of the distinct ages. But when I built this table, I apparently didn't read the question very well, and I did not put distinct ages in here. So hang on, let's you're gonna get a quick crash course in how to build a table differently. All right, 2 seconds. A quick crash course in some more advanced SQL. What is this table called? People. All right, y'all want to see how to drop a table? Y'all want to see how to really quickly ruin a production database? Let's do it. This, those 3 words are how you can nuke an entire table at once and make a database administrator really mad at you. Drop it like it's hot. How the sausage is made. Yes. All right, let's do it. It even has a warning. We've detected a potentially destructive operation in this query. Please confirm that you would like to execute this query. Hell yeah. Let's nuke it. Success. We killed it. Oh. All right, now we need to recreate the table. So we've dropped it, so we need to recreate the basic table. So I've highlighted this query. I only want to run this part of the query for now. All right, so I've dropped the existing table and all the data in it. It's all gone. And here I just ran a create table. So if I do this right now, I'm going to get rid of that drop statement. If I do this, if I run this right now, what will I get?
Cyberkite just followed.
Thank you for the follow, Cyber. If I run this right now, what am I going to get? Select star from people. Congrats, you're now in an FBI database. All right, let's see what we get. Just for kicks. Yep, no rows returned, right? It's an empty table. In some clients, you would just get the headers. You would just see the column headers, but no data. Here in Supabase, they don't even give you anything. 0 rows. Yeah, exactly. Now we can actually insert the data that we want in the table. So here's how an insert statement works, I guess. Y'all get to learn this now. So insert into just like we said, it's plain English, right? Insert into. What table do we want to insert data into? We want to insert data into the people table. What columns do we want to insert data into? We want to insert it into the ID, name, and age columns, right? ID, name, and age. We're inserting data into these three columns. What values, what rows do we want to insert into those columns? Well, here we specify each row on its own line with commas between them. These are going to turn into individual rows in our table. Muckluck says, reminds me of the day the cybersecurity department asked, why are you deleting 4,000 files from a folder called temporary? Yeah, most database clients, just like Supabase, if you try to run something very bad, or potentially very destructive or data altering, most database clients will have some kind of warning or safeguard, but not all. So you need to be very careful what type of statements you run, if you have permissions to do so. However, in most databases or most well run databases, you're not going to have the ability to do this kind of thing. You're going to be able to write select statements or maybe update statements or inserts, but you're not going to be able to do things like deletes or drops. Oh, thank you for the follow, Bloody. The time is 4:59 on a Friday. Confirm table, drop mic, and leave. All right, we're gonna put some duplicate ages in here. So we're gonna have several people be 30. And we're gonna have, yeah, we'll have a couple people be 18. We're gonna have a couple people be 25, and the rest of people are gonna be 30. All right, so I've created some duplicate values here, and then I'm gonna run this insert statement. There we go. Now I'm gonna run my select, and we should see that data in the table. There we go. All right, our table is populating. Yes. Oh, and that's a great point. If you want to create tables like dummy tables like this, there's lots of different ways you can do it. I'm going to tell you how I generated a lot of the data for these tables. I didn't hand write this stuff. I asked ChatGPT to write it for me. So these a lot of this demo data that I put in here, I just said, "Hey ChatGPT, give me a table that matches this create statement." I basically just said, "Give me 10 rows that match this table schema." That's all I had to say. Rian, thank you so much for the Prime sub. My goodness, that's so kind. Thank you. And it didn't cost you anything, which is the great part. But yeah, so you can go to ChatGPT and say, give me 10 rows that match this table schema, and it'll give you an insert statement. You know, to generate this data on the fly, which is a lot faster than typing it out yourself. So that's what I did for most of these. Hey, hello there, Kai. All right, let's go back to the question. This one was age, simple, distinct. Oh, Rianne, I'm glad you enjoyed my SQL streams. A good friend, ChatGPT is. Absolutely, it is. All right, so what do we want? For this challenge, you need to create a simple, distinct statement because you want to find all of the unique ages. All right. So what do they want? They only want us to return age. So if I do a select age from SQL, I get one column return, and it's got all the age values listed out. However, as we know, I have many duplicates, right? There are many duplicate values here. So what do I want to do if I get rid of those duplicate values? Well, what the question kind of already gave it away. What keyword do you think I would need to use if I want to get rid of the duplicate values in my result? We could do a group by. Certainly. We'll try them both. Yeah. So distinct is the keyword that we really want to use here. But let's try group by. See if we can do that. That works. That is technically correct. So you could do that. That and great callback there to the group by keyword. I really like that. It's a great callback. So yes, you could absolutely do that. You could say group by age. However, there is a better way. There is actually a keyword that says, hey, just grab me all the unique values. So we run that and we get the exact same result. Now, what this allows us to do is, as we get into more complex queries, this allows us to do things like select distinct values and also use group by statements on other fields. So the more keywords you have, the more you can use them together and make more complex and varied queries. So we could have used group by for this, but if we wanted to use group by for something else, we could use distinct and then group by something different. So you can mix and match keywords a little bit to get what you want, because usually there's more than one way to do something. Yeah. Dan says, huh, I would have guessed it would be a function. Now, um, in general, the way SQL treats these types of things is that whatever is immediately following the keyword is the thing it targets. So in this case, it's targeting age. So let's say I wanted to distinct age. Let's see, let's try something here. Yeah, so if I do this, select both distinct age and name, the distinct no longer works because there are more names than there are, distinct age values. So it's only targeting the thing that comes immediately after it. So yeah, that's what we want. All right, let's plug it in and see if we did it right. I'm really curious to see if anybody uses the group by statement instead of distinct on the answer. There we go. It worked. Go us. Yeah, and there are such things as functions in SQL. You can have functions in SQL, but what we call these are keywords. These are keywords. Um, Yay! We did it. Select distinct, select distinct, select distinct. Yeah, everybody's using distinct. Nobody's using group by. Nobody was as creative as you guys. I'm disappointed. Come on. I like this one. Select distinct age from people where name not equal to George Bush, and then they put an upper limit on the values returns, which I think that's pretty good. The test fails if you use group by. That's lame. They shouldn't have done that. I wish they wouldn't have done that. You should be able to group it however, as long as you get the distinct values in the end, you should be able to get there however you want. They shouldn't make it fail on group by. Lame. Boo. Okay, and then another thing, let's see, there was something else I saw here that I want to mention. So you saw in a few of these solutions that people did something like this. They said select distinct people.age from people, or select distinct p.age from people p. So you might be like, okay, what the frick is that? That's basically going to give you the same result. So, right, that works. It's the same result. What we're doing here is we're essentially making sure that this age field is coming from the table people. As you start getting into more complex queries, you're going to run into tables that have exactly the same field name. So, for example, you might have two tables and they both have a field called ID. How does SQL know when if let's say you're doing a join or you're doing a subquery or you're involving two tables in one query, how does SQL know which ID value you're talking about? Well, you have to explicitly tell it, hey, this field right here is coming from table people. So that's you're really just you're just saying, all right, p dot age coming from people dot age. So that just tells it what table it's coming from. Drunko Gurama says, waiting for best practices and most clever being Calvin and Hobbes ASCII art. Yeah. Yeah, I think my favorite one was when somebody answered like an 8Q JavaScript kata with the entire script of like B movie, which is pretty great. Yeah. So if you see these types of this type of so this is what's happening here is essentially what we said, what we did before. So I can write it out as this: from people as p. So what did we call this when you use the as keyword and then give it a name? What did we call that? Does anybody remember? When we did it as, we used the as keyword for columns before, right? So yeah, it's an alias. And so this case, instead of a column alias, it's a table alias. We're just making the name of the table shorter so that it doesn't take up so much space when we put it in front of the column name. But because because we assign this alias, the database knows what we're referring to, and we're just like, oh, it's like, oh yeah, this is the people table, and this is the age column from the people table. Yeah. So okay. Oh gosh. Yeah, and really in this case we were able to use both group by and distinct, but if you have a choice between them, where possible, as nanopony says, where possible you should use distinct. um, Group by is often used for assisting with aggregation, as we saw before, like in the previous question. We did a count, we wanted to aggregate that count, and then we had to group by the buckets that we wanted that count to sit in, right? um, and so we had to use group by in that case. But in this case, where we just want to grab unique values, you would want to use the distinct keyword. Now, I just thought it was cool that y'all thought of using group by, because it absolutely works. And but yes, in best practice would be to use distinct. Yeah, from a performance perspective, absolutely. I don't know. I just like it when y'all are creative. It's fun. Okay, we are out of time. Um, but I hope you found what we did cover. I hope you found this valuable, um, and hopefully a little bit fun, and gave you a little bit of an introduction to SQL.
Who just followed?
Oh, thank you for the follow, T. What questions do you have? Yeah, absolutely. Now, oh, before you all leave, would you like to see more SQL next week, talking about things like join and practicing more questions, or do you want to go back to regularly scheduled projects? I'm fine either way. It doesn't bother me. Whatever you all want to see is what I want to give you. More SQL. Okay, I'm seeing more SQL. More SQL. More SQL. All right, you want to see some joins? Absolutely. I do have. So I have a question down here at the bottom. I had it ready to do some work with joins. So it's ready to go for next week if you all want to see it. Um, oh, SQL is going to come in handy with your new job. Congratulations. Okay, lots of jobs in SQL there, and that's true. There are lots of jobs in SQL. Um, Project. Okay, and you want to see how you add data to a database? Absolutely. There. I have another question here. Uh, for somewhere. Where is it at? Oh, this one right here. This is a question about that asks you to add a row to the database. So yes, we will do that one next time as well. Uh, Frankly says, do DBMS keep logs of executed queries? Yes, there's generally a log that's written somewhere that you can query and get the history. Yeah. Power of cross join compels you. Copy says kitten update. Yeah, the kittens are doing good. My 5 foster kittens, they're getting big. They're eating a lot. Um, they're having a little bit of a skin allergy issue right now, but they're okay. They're fine. They're happy. They're playing. They're cute. They're pooping a lot. Kittens like kittens do. Their decade said if jobs equals SQL, then more SQL. Yeah, and that's really true. Jobs may not be strictly for doing SQL. Like I'm not saying go out there and become a SQL dev. Absolutely not. That's not for everybody. Um, But what I am saying is that SQL is valuable for a lot of jobs. As like Rufio mentioned, they are not a SQL dev. They are doing like just regular full stack, programming, right? JavaScript stack programming. But they just told me this past week, oh hey, I'm using SQL at my job now because they're talking to databases, and the best way to do that is with SQL. So it's really useful to know, and it does make you stand out if you can demonstrate your knowledge of SQL. More squirrel. Exactly. As Dan said, most it turns out most apps need a database, and most databases are SQL. Correct. Frankly says, ask about the kittens. When do they learn to poop in a litter box or a sandbox? Yeah, they just kind of figure it out. You don't really have to teach them. You just kind of put one in there, like a little short one that they can get into really easily, and they'll just start using it. It's not like a dog where you have to potty train them. It's kind of nice with kittens. They figure it out after a while. There's a lot of misses at first. There's you'll have a lot of accidents and blankets you have to wash, but they do figure it out after a while. Nerd Girl says it's super useful for data analytics. Yes. So a lot of I started out in my career. I started out as a data analyst. That was my first job out of college. I did data analytics for years. Um, I was a data analyst for way longer than I've actually been a dev. But that's where I learned my SQL skills, was doing analytics and logistics management and operations and that kind of thing, because it's so prevalent in that field. Yeah, Quinn Sab, you can do it. Claim kitten cam on the next stream. I'll show some. I'll show some kittenage on camera. And Nerd Girl says, and everybody uses data, as I've come to find out, but they don't know how to sort it. Absolutely, a lot of folks love to use data because they want analytics, they want insight, but they don't know how to get that data into the format that they need to actually do their analytics. And that's where like people that know SQL and know how to interact with databases, that's where those people come in, and that's where they're valuable, because they can get the data in the format that people actually want to get those insights. Yeah, absolutely. And the last thing I wanted to mention too, this is kind of the kind of thing that comes up. So the type of thing that might come up in an interview, as what type of language SQL is. So as you've probably noticed, let me get one we've already done here. It's a good one. So, for example, like this one, as you've already noticed, SQL is written in a very it's written like a command, right? Like you are telling, like I said, it's at the beginning, it's like the computer from Star Trek. You're telling it to go do something, right? Go get me that. Go fetch me, go fetch me this information. And I want this information in a certain order. Now, what you might have noticed is that we're not telling, nowhere in here are we saying how that should be done. We're saying what we want and how we want it to look, but we aren't writing like a function that loops through the data and sorts it and orders it, right? We're not actually telling the compiler how to do this. We're just saying what we want. And so SQL is actually a different type of programming language than JavaScript is. So SQL is what we call a declarative language. We are telling the processor how to do what we want, right? What do we want? What do we want to see when we get it back? But we're not telling it how to do that. It's that frees up the database to allocate resources and perform operations in whatever order it sees fit, as long as it comes back with the result that we ask for. So it can reorder processes, it can change the order of rows, it can put things in whatever order it wants, as long as in the end what we get back matches what we requested. So SQL is a declarative language, which means that you are telling it to do something, but you don't care how it gets done. So just something to put out there. It's the kind of thing that you can impress an interviewer with. If they're what's the difference, and you'd be like, well, SQL is declarative, and this is why. So Adds the inky deck. Yeah, that's the kind of thing actually you might want to add. Um, you can spit some facts and maybe impress somebody. As Quinn said, yeah, it's a non-procedural language. JavaScript is, JavaScript is procedural. You're setting out the specific steps to follow in order to get the result in JavaScript, right? You're writing the functions. You're specifying everything down to the nth detail. You're laying out all the logic that needs to get done to eventually get the result that you want, right? You're not saying just give me this. You're saying, all right, this is how you do it, in what order, and exactly how those steps should be done. Whereas SQL, you're talking about the end result, and that's what you're requesting. You don't care how it happens, and that can be a good thing and a bad thing. A lot of the times, it's a great thing because it allows the database to allocate resources based on other things that are going on that you don't know about, right? You could have 1,000 people writing queries, and the database needs to balance those queries and return them in the most efficient way possible. And by just saying, hey, give me this stuff, you're giving the database the freedom to move things around, to change logic, to do whatever it needs to do in order to be as efficient as possible. The bad thing is when the database gets it wrong and things it does things in the wrong order or chooses the wrong way to do things that's inefficient. So it's a double-edged sword, right? um, yeah, absolutely. So it's just kind of an interesting thing about the way that SQL operates. It's all focused on the end result, and you turn over all the nitty gritty to the database itself. You don't have to worry about that. Nerd Girl says, "Is it wrong to say low key reminds me of Excel?" Yeah. So Excel is actually has Excel has a very long history. Excel is based on earlier software, which dealt with spreadsheets, things like Lotus 1 2 3, and even older stuff. And all of that is based on like essentially it's based on the table model, right? You have rows, you have columns, and you do operations on those rows and columns. And so as you go back in time, the two sort of converge as far as concepts. That's why they are very similar, because they're both table based, and there's you perform certain operations on tables and spreadsheets. um, it's all tabular data, right? As Dan said, it's all tabular data. When we say tabular, what we mean by that is table based data. So that's another good word to know. You might hear the word tabular thrown around. They don't mean tabs. What they mean is tables. Tabular means data in table form. So that's another good keyword, tabular. Table based data. Yeah. I'm just reading through the rest of the chat here. It's like filtering in Excel. In SQL, we use the filter in the workflows. Yeah, exactly. What you'll find is that there are similarities to how Excel analyzes data to how you would write a SQL query. So if you've ever built a pivot table, um, you put fields in the columns, you put fields in the rows, and then you can put something in like the values column. And what pivot tables do by default is they essentially do a group by. They take all the distinct values in your rows, and they aggregate them down. And then in the values, they'll do a sum, or they'll do a count, or whatever. And that's literally what we just learned how to do in SQL. So things like pivot tables are doing a lot of the same analytics that you do in SQL. The thing is, it's all about volume. SQL queries are much more efficient at handling mathematical operations and aggregation and stuff at scale. If you tried to build a pivot table based on 6 million rows of data, number one, Excel sheets can't even hold that much data. And it would be extremely resource intensive on your computer. And that's the kind of thing that SQL is literally made for. It's really good for handling large scale operations on very large data sets. So, for example, at my work, I work for a major university, and so we handle huge amounts of data. So, it's rare for us to have a table that's under 1 million rows. Most of our tables are over 1 million rows with 10 or 20 columns, and we have tables that are up to like 25, 50 million rows. And so you need to be able to do things to that data at scale. And so that's what SQL is really good at. Oh yeah, and SQL Lite is another great Yep, free SQL databases you can try out. Absolutely, SQLite is really good for that too. Uh, Tifu says, how many columns do you think is too many? That's a great question. Um, so the main goal of SQL is to break your data down into tables that make sense. So tables that are self-contained and data that is relevant inside. So data that is related inside of that table. So your tables should be, pretty self-contained and pretty self-explanatory, containing data that is so every column should be relevant to the other columns in some way, right? So if I have a customers table, I shouldn't have, any like I shouldn't have product names in there, because that belongs in the products table, right? The data should be relevant to what table it's in. Um, and so you want to break those tables apart when you can, and keep them as small and self-contained as possible. But there's really no um, I can't say like a specific number for how many columns is too many, because sometimes you have big tables that do all contain relevant data, and especially when you get to like big enterprise level systems. Um, so yeah, I mean it's that's a tough question. But the larger your table becomes, I'm talking columns, the more columns your table starts to have, the worse it will perform. Whenever you try to do anything with that table, it's going to get bogged down. You're going to have a hard time accessing data inside the table. It's going to take up more resources every time you access it, and so it's going to become more of a problem. So you need to think about, are there columns I can get rid of when you start to see a performance hit? Are there columns that aren't being used anymore? Um, can I break this apart into two tables? So at work, we actually do that. We have things like employee data. So I work with some employee data. Our employee table got so large and has so many columns that Oracle, which is our database software that we use, actually couldn't handle it anymore. Oracle was like, nope, screw you. I can't even deal with this table anymore. So we had to split it into like employees one and employees two. And then what we essentially do is we join those tables back together on a common field. So the basically the ID field. Each row in both of those tables has a unique ID. We join those IDs back together, in a what's called a view, to create what looks like a unified table, even though in the database it's actually two, because it has like 150 columns or something. We just had to split it in half. Exactly, as Paranoid said, there's a max packet size and bandwidth starts. Yeah, you start to just use way too many resources to access a very large table like that. And what that's called exactly, as Frankly mentioned, what we call when we figure out what structure, how what fields go in what table, how we break those apart. That's something called normalization, and that's another great keyword to know. It's called normalization when we figure out what goes in what table and how to make the most efficient structure possible. And there's certain rules to that, as Dan mentioned. There's certain rules to that to help guide how normalization should look. But when you're building a database, yeah, you got to think about normalization. What do you want to go where? Sushi says we use Oracle too. Yeah, are you Sushi? Are you at a big like enterprise type company, like a big kind of like, I don't want to say legacy, but like, you know older company? T says, thanks for the detailed answer. I work on some databases at work that are used for documents reports. Hundreds of fields, hundreds of fields in every document. Never sure if we should have lots of tables for that or one big table. Yeah, and I mean, it depends on what data is in the documents. If if all the fields from every single document have to be accessed every single time, then yeah, it's probably going to have to be in a single table, because otherwise you would be joining multiple tables together to get the information that's in the document every single time. However, if some of that data isn't used very often or not necessary, you can either consider not writing it to the database at all, or putting it in a separate table that only gets accessed occasionally. So that's one thing you could think about, is if all the data isn't being accessed all the time, some of that data could maybe be put in another table that's only accessed rarely. and then you'd have the regularly accessed table or sorry, regularly accessed data in a in a table of its own. That's what database architects are for. There's certain people whose only job is to think about that kind of thing all day, every day, and come up with the best possible structure for a very large database. Nergal says, I've seen a lot of talk about Oracle using cloud databases, or I've heard that they build their own servers to hold their data. Yeah. Um, and yeah, Oracle is really for mostly large scale data storage and manipulation. Like we're talking like enterprise level. So yeah, they have cloud options and they have on premises server options. John Grandma says foreign keys and normalization was an interview question for me. Yeah. So at the very least, you should know what normalization means. Um, it's a helpful keyword. Dan Kincode said, in NoSQL docs, it's all about denormalization, right? Taking things out of buckets and making them individual self-contained documents. Yeah, that's kind of the whole driving principle behind NoSQL databases. It's a different approach for building collections. Not sold, it's better for most use cases. Yes, there are a lot of drawbacks to denormalization. Yes, you don't have to do a bunch of joins every time you want to access a certain set of data. So if you have a small like set of data that's being accessed a lot, yeah, you could store each transaction in an individual document, retrieve that document when you need it, and you have everything you need in a single document. However, as your documents grow in size, you start to become inefficient because your documents become larger. You're retrieving the entire document every single time. You don't need all that data. You're using too much extra bandwidth. Yeah, there's a lot of drawbacks to denormalization as well.
Doug just followed.
Oh, thank you, nerd. Thanks for the follow. So that's why for very transactional data, so for stuff like where you have transactions coming in from outside systems such as like customer, like such as like stores, like department stores, or like the data that I work with, like student data, student data coming in from things like meal swipes, from class registrations. That's all very transactional data. That's the that is made for relational databases. The normalization versus denormalization, SQL versus NoSQL. I found it really helpful to. There's a book out there called what is it called? Um, Designing Data Intensive Applications.
Just followed.
Thank you, Sasha. Thank you for the follow. There's a book called Designing Data Intensive Applications, and I think it's fairly cheap on Amazon. And it talks about, yeah, if you are building applications that use a lot of data, what type of database should you use? Should you use a NoSQL database? Should you use a relational database? And it talks about the pros and cons of document based versus table based databases. Um, and I really, I mean, it was a great take, and I really appreciated it. It's pretty it ends up a little bit more biased toward relational databases, but it also talks about some of the drawbacks. So, Dan, if you're interested in exploring more of the pros and cons of database types, you might want to check out that book. It's probably at libraries and stuff too. You can probably find it for free online somewhere. And frankly, Ben mentions that there are other database types, and there absolutely are. So there are database types beyond relational and document based databases. There are other types out there. And in particular, there are types that are made for specific, very specific use cases, because sometimes none of the existing types are going to work, and you just got to come up with something new. So, for example, geneticists, like people who work with DNA, they had to invent a brand new database type just to store the type of genetic data that they work with because no existing type was meeting their needs. So they have their own type of database that they use. And so, it just depends. There's a bunch out there, but by far the most common is relational. So SQL databases, like what we've been working with here, by far the most common, and one of the oldest types out there, uh, followed by document based or NoSQL databases. Nerdgirl says, "What was the name of the book again?" Um,
John Yinson just followed.
thank you, John. Let me see if I can find it. And I will warn you, it's not light reading. It's very but it's not bad either. It's not overly technical. It's more about the concepts. Here it is: designing data intensive applications, um, and it's by Martin Kleppman. There you go. If you're interested, you could probably find it at your library, or maybe even like if your employer has a library or something like that, you might be able to find it there, or free online. I don't know. Sushi says, we have like hundreds of millions of data. I'm glad I'm not part of the database team and data warehouse folks to do. I only pull data and create reports for my department. Yeah. So there's probably somebody on the database side whose only job is to structure that data and figure out what data goes where and try to make it perform most efficiently. To be clear, that's not the work that I do in my day job. We have two people on the team that I work with who that is their job. They think about data structures, they think about efficiency, they handle that kind of thing. I don't. I build stuff. I'm a maker. I build stuff. And I fix stuff. I'm down there and in the pipes with a wrench and beating on stuff until it works. So I don't do that the bird's eye view type stuff. If they tell me to build something, I build it. Dan says, to me, it's very strange how NoSQL is marketed. On one hand, the tech is made for massive scale. Yeah. Solving problems where you normally have to shard a relational database. But it's also sold as easy to get started and connect your app to their service. And yet everything in those between those 2 points seems harder than SQL. Yeah, it kind of does. Um, it's great for small apps and it absolutely does have its use cases, but I don't often see document based databases doing something that a SQL database couldn't. Um, and then relational databases can do more. So I mean, look, it's like like I always say, it's about the best tool for the job. Sometimes the best tool for the job is going to be a document based database because it interfaces well with your app. You can talk to it using JavaScript and Mongoose, and it's easy to connect to, and you don't have to use fancy tools to translate between SQL and JavaScript, right? Sometimes that's easier. But then sometimes your app starts to grow and your documents get bigger and it no longer fits in a document based database. So then you might have to migrate to a relational database. It just depends.
L underscore Chronos
Thank you
says
so much for
L
the follow,
just joined.
Kronos. Kronos says, what is 100 Devs? I'm so glad you asked. So, 100 Devs is a free way to learn to become a web developer. So, if that's something that you're interested in, don't pay for a boot camp. Your time is valuable. You shouldn't have to pay on top of that you shouldn't have to pay money on top of the time that you spend to learn these skills. And so 100 Devs is a free online community with a massive Discord and a bunch of videos that will take you from not knowing what the word HTML means all the way up through building full stack apps. So I highly recommend it, and it is truly free. I'm not BSing you here. Um, from start to finish, no cost, a great community, and I don't know, my opinion, a lot of fun. I went through it. Um, I started out not knowing how to. I thought websites were magic like 2 years ago, um, like straight up wizardry. And I mean they are, but at least now I know how to do the wizardry. So now I can build full stack apps in like an hour. So I mean, yeah, it's a great community, and most of the folks in chat here are at one point are part of that community or have been part of that community. Renit says, does a relational database have a way to handle text of unknown size? Or is barcode there the only way? Yeah, so as an example, what I sometimes encounter at my work, like I said before, we get data in from a lot of different systems. So things like card swipes, which are very transactional. You get kind of very set data, fixed data that's coming from a computer, right? A computer is gathering some data and it's sending it to the database. But on the other hand, what we often get is data that's being entered by humans. So things like online forms that humans fill out, like job application type stuff. Um, and what we have sometimes is people who try to put an entire novel of their life story in a field that was really only meant for like 100 characters. They go and they literally copy and paste their entire 6-page resume into this field that was never meant to hold that much data. And so one of the drawbacks, and I will say one of the drawbacks of relational databases is that you have to pre-specify how wide, how much data that column can hold. So when that happens, and it does happen, we have people who try to put 6 pages of words in a field that was set as a varchar with a length of 100. Then what happens is we get an error, and then we have to go in and we have to increase that column size. And so that's a drawback. That's a place where a document-based database wouldn't care, because it could be like, yeah, sure, whatever. You want to put a freaking novel in here? I don't care. Do it. So that's one place where a document-based database is more flexible. When you have very variable and user created data and human entered data, then that can be helpful. So to answer your question, not the relational databases really don't handle text of unknown size very well. Now, there are specific types of fields that you can use to handle that, but they aren't necessarily native to SQL. So there's things like CLOB fields, which are for like holding entire HTML pages in a single cell. So like here, this could be like an entire HTML page, or handling JSON data, like Dan said. I mean, you can set up objects in most modern relational databases now. You can set up fields that are actually objects, like a document. So there are ways you can do it, but in the strict definition of SQL, no, you have to pre-specify column size. So it just depends. Again, you can really tailor your database to handle certain data types, but it does involve some forethought, because you create all the structures beforehand. Sushi says, Claire, are you planning to be a software engineer or keep your current job as a data analyst? Actually, I'm actually currently an engineer. I was a data analyst for many years, but now I'm a senior SQL dev. So yeah. But on the side, I build full stack apps. I don't do that at all in my day job. This is me building all these projects and things on stream is really just for funsies, because I like it. It's fun to do something different than what I do all day at work. Although I do love showing folks, stuff like this. This is really fun for me too. Um, so yeah, I'm currently a senior SQL dev for funsies. Yeah, it is fun. I mean, genuinely, I wouldn't be doing this if I wasn't having fun. Yeah, that's what I always say. I mean, if I ever stop having fun, then I just won't stream anymore. But I'm having fun. Fun stack, yeah. As Ryan says, I'm a fun stack developer. That's pretty much it. I don't have a stack. I just whatever's fun at the time. That's what I'm going to develop with. Yep. For the heck of it is pretty much why I do stuff, and because it's fun to watch. To hang out with chat for a few hours every week. But Sushi asked, if I mean, are you looking for a software engineering position? I mean, if the right other position came along with the right compensation and benefits, if you're offering, hit me up. We'll talk. That's part of the tech industry is you're always on the lookout for bigger and better things, right? So anybody out there in chat, y'all have seen what I can do. Y'all know my skill set. If somebody's got senior level opportunities out there, feel free to hit me up and we can talk. All right. Any other questions? You all have been asking some extremely excellent questions about SQL and databases, and I love talking about this stuff. So feel free to ask if you got any other questions, or if you got questions about me, about 100 devs, whatever you want to ask. I'm an open book pretty much. I'm going to hydrate real quick. I'm getting a little scratchy. Hmm. Dan says, what do you think the next stream will cover? Well, based on what I asked before, it sounds like folks want to see more SQL. So we'll probably talk about some more advanced topics. And not by advanced, I'm not talking about anything crazy, but we're going to talk more about other types of things that you can do. So things like joining two tables together. So for example, let's talk about a hypothetical. What if I had one table that was called orders? So it has transactional data about the things that people have ordered, and it has things like, how much did they pay on that order and that kind of thing. And then we have another table called products. So if I wanted to get the name of every single product and how many of that product had been ordered month over month, I would have to combine data between the products table and the orders table. And since we're working in a relational database, you better believe that there are ways we can do that. One of the fundamental things we talk about breaking data apart into tables, but the other major strong suit of relational databases is then linking those tables back together to get almost infinite combinations of data and values. And so we'll talk about that next time. That's what's called a join. So we'll talk about joining tables together to get combinations of data from different tables. So we'll practice that a little bit. What else do we got here? We'll talk about nulls and working with null values. We'll do some more practice with grouping things together. We'll do some more practice with like mathematical logic, more practice with case statements. Yeah, grouping, sorting, ordering, joining. Yeah, I think that, and also things like min max, so min values, max values, and also subqueries. So a little bit of talk about subqueries as well. Oh, Mo too. I'm glad you had a fun time. That's awesome. And remember that there are resources that you can that you can use for free that can help you really learn SQL start to finish. So there's things like SQL Zoo. I think that's an older resource, but I mean, SQL doesn't change very much. There's SQL Bolt. There's W3 Schools, which has a sandbox where you can write your own queries and see what they do. So you can test some of the concepts that we covered today, and try them out for yourself, mix and match, try different fields and that kind of thing. Yeah, and SQLite, where you can build free databases. This database was, if you want to build some databases, your own database, you can use something like Supabase, which we're using today. And also, ChatGPT is really good at writing SQL and also troubleshooting SQL statements. So if you write a SQL statement and it's not working and you don't know why, just put it in ChatGPT and GPT will tell you what's wrong with it. Because SQL is so similar to English, ChatGPT is really good at working with SQL. It's really accurate, and it's helped me with a lot of the really complex queries that I do for work. The ones that are easy to mess up, it helped me a lot with those. So just a couple of resources for you. Dan says, do you work with any APIs connected to databases you work with? You mentioned pipelines. Not sure if it involves those APIs. So I don't really work with the APIs themselves. I really work with getting the data out of the APIs and then doing stuff to it and loading it into the database. So it's more about the pipeline, the transmission, than the. Whoops! I just dropped my phone. It's more about the transmission of the data than working with this. I don't really work with the sources at all. All I want is the stuff that comes out of the sources. Dan says you can relate documents in NoSQL, but it often involves praying the string IDs match. Yeah, you can do relational operations in document-based databases, but yeah, they aren't made for that. Literally, they aren't. And so you can do it, but it's not native, and so it's much harder to do. Alrighty. So next week, plan on more SQL. We're gonna probably. I think this format worked pretty well. I hope it was helpful for you to be able to build the queries in real time and see how they affect the database and kind of play around a little bit. I feel like this worked really well and was hopefully a nice illustration of what SQL works, what SQL does, and how it works. So I'll probably add a few more questions to the list. I'll get rid of the questions we've already done, and yeah, we'll have plenty of content for next week as well. And we'll also review so we'll also review the concepts that we talked about today, just because it'll have been a week later, and you forget things, right? And so we'll do a review first, and then we'll get into some new stuff. Awesome, Dan. Thank you, Copper Lily. Dan Code says, Mine Wolf, what's the slowest query you've seen? Yeah, I've had queries that last like 10 minutes. It takes 10 minutes to get a result back. Um, and it's a lot of these things, they're on fully indexed tables. They're just incredibly complex, gnarly queries that are against really massive tables. And so sometimes it just happens. You have queries that'll last 10 minutes, 5 minutes, stuff like that. You just got to walk away and get a cup of coffee. Yeah. Looking forward to next Sunday. Thank you, Copper Lily. Appreciate it. Thank you, Dan. Thank you, Nerd. Thank you, Rex. Thank you, Engineer. All right, let's find someone to rate, shall we? Let me know if you have any. Let me know if you have any suggestions. Well, yeah, it's mostly just the volume of data, Dan. You know, it's just a crap ton of data. Can't even tell you. All right, let's get that pulled up. Thank you, Chris. Thank you, Renee. Thank you, Sushi. All right, looking for a raid target. Feel free to suggest somebody if you have somebody. Let's see who we got. Ba-ba-ba-bum. Ba-ba-bum-bum. All right. We got Zorschenheimer. Zorschenheimer is building. They're building it's a Nintendo, like the NES, the classic, like Mario NES. They're building an NES game.
Typer 124 just
Thank
followed.
you for the follow, Typer. We've got Team Vash. They're building something. I forget what they're building. Um,
Dev just followed.
oh, thank you, Digoman Dev. Thank you so much for the follow. We've got Eduardo. I think they are only they're a non-English language stream right now, so I think we may not want to read them. Um, Brandon says I have to bomb the final of Query in next 2 days. Good luck, I guess. Oh, so all right. Any suggestions on somebody to raid? Anyone playing Baldur's Gate 3? I tend to prefer to raid folks who are in the software and game dev category, just because it's a small community and we like to support each other. I can see who's online in that category. I think we've raided both Zorschenheimer and Bash very recently. Um, oh, just in general. I have not played Baldur's Gate 3, but it does look pretty good. Just asking chat. Sure, yeah. So, chat, anybody out there playing Baldur's Gate 3? Dan Can Code wants to know. Manny Moki. Okay, let's see. Check them out. Let's see, somebody spell it right. Manny. Oops. Manny Moki. Oh, yeah. What are they up to? They are, I can't quite tell what they're doing, but they're doing something. All right, we'll raid Manny Moki. Looks like they're working on something or other. So be sure to show them some love, and I'm going to send you over there now. All right, everybody, have a great week. I will see you all back here next Sunday for more SQL. Let's go. All right, starting the raid now. All right, have a great rest of your day. Be safe. Talk to you soon. Bye bye.